We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we are HackerFrogs. We're going to be doing 3 different cybersecurity activities today, and what we're going to be doing first is we're going to be doing HackerFrogs after school ELF reversing. Well, maybe not ELF reversing, but we're going to be learning about some reverse engineering stuff with maybe it's not Try Hack Me today. Maybe it's PicoCTF. I need to change the title of this slide over here. But this is what we're going to be doing first. We're going to be doing some reverse engineering fundamentals, and that's going to be the first hour of today's stream. In the second hour of today's stream, we're going to be going through the Bandit CTF. And the Bandit CTF is a very well-known CTF series of CTF labs from overthewire.org. And this is where you learn about how to use Linux and how to do some security stuff in Linux as well. So please look forward to that in the second hour of today's stream. So that's going to be the second hour, and in the third hour, the third and fourth hours, maybe, we're going to be doing some Linux hacking. And the Linux hacking we're going to be doing is against the challenges over at Dockerlabs.es. So Dockerlabs.es is a Spanish language hacking cybersecurity education platform, and we're going to be doing the WalkingCMS challenge over here. So WalkingCMS, that kind of indicates to me that we're going to be doing some web app hacking, and we're probably going to be taking over some sort of content management system, otherwise known as a CMS. So please look forward to that in the third and fourth hours of today's stream. But let's get started with the first hour of today's stream. So the first hour is we're going to be doing some reverse engineering. And as such, we're going to be talking about the definition of reverse engineering and how it pertains to cybersecurity and CTF games, or capture the flag games. So welcome to HackerFrogs After School. It's a cybersecurity program for learning beginner cybersecurity skills across a wide variety of subjects. This workshop is the intro class to reverse engineering. So what is reverse engineering? So according to Wikipedia, reverse engineering is a process or method through which one attempts to understand through deductive reasoning how a previously made device, system, process, or piece of software accomplishes a task with very little, if any, insight into exactly how it does so. So we're not exactly going to be doing very difficult reverse engineering in today's class. We're going to be doing some reverse engineering based purely on the instructions that we see in the software. So in the case of cybersecurity, we'll be focusing on software reverse engineering, and in the realm of software reverse engineering, we're going to be focusing on ELF x86 ELF binary executables. So you might be thinking to yourself, what are x86 ELF binary executables? Well, let me explain. So executable and linkable format ELF, this is the standard format for executable binary files on Unix-like devices, such as Linux. But what about this x86 that we're talking about? Bubblegum says, can we do race condition? So race condition is not this subject. We're doing reverse engineering, not binary hacking. When we do binary hacking, race conditions are going to be one of the topics. They're probably not going to be one of the beginner topics because we generally teach beginner skills around here. But you might want to look out for another course on binary hacking before we start talking about race conditions. So what are we talking about when we're doing x86 reverse engineering? Bubblegum asks, when are we doing binary hacking? So binary hacking is going to come later. We might be doing binary hacking sooner rather than later, but you might want to take a look at the schedule for HackerFrogs if you want to know when it's happening. So we've got a Reddit, and let's just pull it up, and I'll leave the link in the chat. So we publish a schedule for our weekly streams, and you can find the topics that we're going to be covering. Oh, okay, so we're going to be doing some binary hacking on Wednesday. So we're going to be doing our intro to binary hacking on Wednesday, so please look forward to that. Okay, where were we? Okay, so we're talking about the x86 chipset. So when we're talking about computer architecture, there are generally a few different popular types of chips, and x86 is the most popular type of chip for personal computers, that is PCs, as well as laptop computers. So when we're talking about laptop computers or PCs, we're generally talking about the x86 chips and those kind of instructions. So Bubblegum says MIPS, RISC-C, CISC, ARM. Yeah, so those are some other chipsets, and they all have their own type of assembly instructions. In our case, we're going to be talking about the x86 chipset. So this is the most common CPU chipset used for PCs, desktop, and laptop computers. So we're going to be learning the assembly language associated with it to study reverse engineering. So we're going to be talking about assembly language. So there's not just one assembly language. Each chipset has its own assembly language. So there's x86 assembly language. There's also ARM assembly language and RISC-C assembly language, basically one for every chipset. So assembly languages are the lowest level programming languages for any computing device. So when we say low level, we don't mean that it is inferior. We just mean that it is closer to the raw computer instructions that exist on the CPU. So in this context, it means closest to raw computer instructions. So there's no one assembly language, but there's a separate assembly language for each type of computer processor. So the platform that we're going to be using to learn about reverse engineering today is the PicoCTF platform. And it's a very well-known and well-respected CTF platform that is affiliated with Carnegie Mellon University. So that's a major university in the United States. So the PicoCTF platform has many different challenges across different categories and difficulty levels. For this lesson, we'll be looking at PicoCTF challenges in the reverse engineering category. So to learn more about x86 assembly programming, we're going to be taking a look at this challenge from PicoCTF. So this challenge is called the BitOASM 1 challenge. If you don't have an account over at PicoCTF, you can very easily make one by going over to this link over here, so picoctf.org. And if it's not a very difficult process to sign up, and it's also free. So everything is very easy for us to do this. So after you've logged into picoctf.org, then you can go over to this link, and this is the link for this challenge over here called BitOASM 1. So let's go ahead and go over there. So once you've logged into PicoCTF, what you want to do is you want to go over to the practice page. So the practice page is going to have all of your challenges. So go ahead and go there, and once you're there, you can paste in the link and navigate to the challenge. Bubblegum says, I'm going to join up later. Okay, no problem. We'll see you in a bit. Okay, so let's go ahead and give Bubblegum a Hack the Planet to see him off.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so what's going on in this challenge over here? So inside the challenge, it's called BitOASM 1. The description says, can you figure out what is in the EAX register? So put your answer in the PicoCTF flag format, that is PicoCTF, and then inside the curly braces here, you put N, where N is the contents of the EAX register in the decimal number base. So in this case, it tells you if your answer is in hexadecimal here, so hexadecimal 11, your flag would be PicoCTF 17, because hexadecimal 11 translates out to decimal 17. And they've got a little download link over here. So what we can do if we really wanted to, and I guess we might as well get used to using the PicoCTF web shell, because why not? We're gonna go ahead and access the PicoCTF web shell to solve the challenge. So let's go ahead and open up the web shell. So on the practice page over here, if you scroll down a little bit, you're going to see that the web shell button over here is on your right-hand side. Go ahead and click on that. and that's going to open up the web shell. You're going to see this message over here. What we want to do is we want to make the web shell nice and big so that we don't have to strain our eyes to take a look at it. And we can do so by going over to the top of the picoctf web shell interface and then click on the button that is to the right of the help button. So the button to the right of the help button is labeled Pop Out Web Shell Terminal. This is going to put the web shell in its own browser tab. This is what we want. So go ahead and click on that. So if for some reason the web shell doesn't start up when you click on it, it might be because the browser, because the picoctf server is not very responsive. In that case, you can go ahead and repeat the process a couple of times until it actually works. So it looks like it's not very responsive in this case. We can try reloading the page. Okay, so after we reloaded the page, then we got our response. That's great. Okay, so from here, you're going to see this startup message here. This is a little Linux virtual machine, and where we can solve the picoctf challenges. So after we arrive here, we can go ahead and clear the screen by typing in clear. And let's take a look at what is in our directory. Okay, so it looks like I've got a bunch of stuff in here. I'm just going to take this opportunity to clear out some of this clutter. Okay, and what we're going to do is we're going to download the file that's associated with the challenge, bit.asm1. So let's go ahead and go back to that page. So just in case you were wondering, this is the link for the challenge. Okay. And we can see that the download for this challenge is located at this link here. So we can right click it and then select copy link. So right click on the link, select copy link. Then we're going to go back to our web shell. So remember, the web shell is in another tab, and it looks like we've been disconnected. That's fine. We can press enter and reconnect. Okay. So let's go ahead and download that file. So we're just going to download the file with the wget command. So type in wget and then space, and then right click, and you can paste in the file address for this disassembly text file. So go ahead and hit enter after that, and that's going to download the file. So if you're wondering what command we're using, let me just paste this into the chat. So if you're having difficulty, you can go ahead and copy that entire command there from wget until the end of the file name. And then in your web shell, you can right click and you can select paste, and that's going to be the command. And then you can hit enter to run the command. All right, but anyways, we're going to see that we've downloaded the file when we do the ls command. So everybody, if at any time you get stuck or you get stuck on a step that we're doing, please let us know in the chat, and we'll try to help you out if it looks like it's not going to take too much time. I prefer that this be a conversation, and I prefer that everybody be on the same page. And don't be afraid to tell us that you need some help. So we can read this file here by, well, actually, let's go ahead and use the Nano program to read this. So Nano is a text editor, and we can go ahead and use the Nano command to open up this file. So type in Nano and then space, and then start the name of the file, which is disassembler. This is a really long file name. So what we're going to do is we're going to start typing in the first couple letters, and then we're going to hit the tab button to autocomplete the name of the file. So that's a very CypherFreaks asks, what is the name of the challenge? The name of the challenge is bit.asm1, and let me get the link for you. So we're just going to use the Nano text editor to take a look at this disassembly output over here. So let's go ahead and do that. And we see that we've got a bunch of assembly instructions in here. So I'm going to go ahead and move these instructions to the middle of the screen so that you can all see it better. Actually, I think I can increase the size of the font as well. Hold on. Let me save this out, and then let me make the font bigger. Okay, now the font is super big. So let's go ahead and take a look at that file again. Okay, so you should be able to see these instructions over here, and we're going to be talking about what exactly is going on in this disassembly over here. So when we say disassembly, what we mean is basically we're getting the instructions that the program is going to run, and these are the instructions that are running in this program, this example program here. So we'll talk about what exactly these words mean, these different instructions, in just a second. So let's go ahead and do that presentation over here. So when we talk about x86, which is the assembly language that we're looking at, we have to understand some concepts. And one of the concepts that we're going to be talking about today is memory registers. So the challenge talks about the EAX register, which is a storage location in a CPU's memory. So on a CPU chip, there are some super fast memory that is known as the CPU memory registers. So these are basically little locations where you can store data on the CPU, and there are many registers in x86 CPUs, but for now we're just going to talk about these 4 commonly used registers. We've got EAX, EBX, ECX, and EDX. So basically these are all locations where you can store your data before it's run by the CPU. So this summary here shows what kind of data the registers were intended to hold, but any register can hold any data for any purpose. So originally the EAX register was used for primary arithmetic, and EBX was used for memory addressing, ECX was used for loop or string counters, and EDX was used for multiplication operations and such. But in reality, these memory registers can hold any type of information, but it's just what was intended for these memory locations. Okay, so you'll notice that when we opened up the file with the disassembly instructions, there are a bunch of these instructions over here. So in the assembly program dump, we see that there are 5 different types of instructions. So each one of these instructions here is going to do a different thing inside of the CPU and with the CPU memory. So if you're wondering what these over here are in this first column, these are the offsets, basically the offsets for where these instructions would be inside of the program memory. So for example, the first instruction would be at offset 0, and then the next one is at offset +4, +5, +8, etc., etc. So we're going to talk a little bit about what these instructions are before we tackle the challenge. So the push instruction. So here, oh, there was another. Oh man, did I forget? Okay. So the first instruction is the NBR64 instruction. And the NBR64 instruction is basically in the instruction that starts a function. So we can think of all of these instructions right here as a programming function. And the start of the function is going to start with this instruction here, NBR64, and it's going to end with the RET instruction. So Shellback says, do you have video list for reverse engineering beginner? I don't. This is a program that this is a course that I'm currently developing right now. So I don't quite have videos yet, but if you're interested, you could probably find a lot of materials for learning about reverse engineering on the PicoCTF site over here. So let me see if I can find it really quick. So learn and then resources. And let's see if we can go over here. So challenge video tutorials, learning guides. Okay, they've got a learning guide for reversing over here, and they also have a YouTube channel. Okay, so let me go ahead and leave that link in the chat. And I'll leave the link for the reversing PDF on PicoCTF as well. Okay, so we just have to remember that all of the functions inside of assembly are going to start with this instruction here, NBR64, and they're going to finish with the RET instruction here. But what about all these ones in between? Let's talk about them. So the first instruction we see here is the push instruction. So the push instruction is used to put data on top of the memory stack, which is a special storage location. So you might hear about heap memory and stack memory, and we'll talk about those in a later lesson. But for now, you just need to know that the memory stack is a special storage location for data. And the other thing that you have to understand about the stack is that it's like putting information on top of a bunch of plates. And so if you put information on the stack, each piece of information is going to stack on top of each other. And that's why they call it the stack. So the push instruction is used to put data on top of the memory stack, which is the special storage location. So the next 4 instructions over here are all move instructions. And the move instruction is it's basically the fundamental instruction of x86 assembly, and this is used to put data into a memory register. So you're going to see a lot of these move instructions when you take a look at x86 assembly instructions. And the way the move instruction works is the first operand, which is the first piece of information after the instruction, that's going to be the register that's going to be affected. So move into the EAX register, and then the second operand is the data to be moved. So move into the EAX register the value hex 30. So hex 30 is 3 times 16. So 3 times 16 is 48, I'm pretty sure. So this is going to be the value 48. It's going to be put into the EAX register. That's what this particular move instruction does. So in this example, the hex 30 value is moved into the EAX register. And the last 2 instructions here, there's the pop instruction. And the pop instruction is used to remove the first value off the memory stack and to move it into the memory register. So the memory register RBP is going to be populated with whatever is on top of the on top of the stack memory. And the last instruction is the RET instruction. And the RET instruction is used to finish execution of a programming function and return to the execution of the main function. So you can think of program execution as going from top to bottom. And if there's a function that runs at instruction number 3, the program execution is going to jump over to the code in the function. And then after it's done, it's going to jump back to the instruction immediately after the function instruction, which would be instruction number 4. So basically, the RET instruction is to return to regular program execution. Okay, so let's go ahead and solve the challenge then. So let's go ahead and take a look at what is in the web shell. Okay, so luckily the web shell didn't close while we were doing our presentation. That's great. Okay, so the challenge in this case asked us this question. Oh, where's the challenge? Let me get the challenge. So the challenge asks us, can you figure out what is in the EAX register? Let's go ahead and figure out what is in the EAX register. So this is, well, we pretty much solved the challenge already, but let's go ahead and make sure we understand what's going on. Thank you very much for following DJ Kinetic. Thank you very much, and you are now HackerFrog. why don't you have a nyan cat on me? Okay, so let's take a look. So the only register that we have to pay attention to is the EAX register. If you want to pay attention to only a certain register, Sick in the Mind says, good day, Sick in the Mind. Nice to see you here on Twitch. And we're just doing some very basic x86 assembly stuff over here. And we're learning about some basic concepts about all the instructions and what they do. But welcome to the stream. All right, so if you want to pay attention to only one type of register, you're going to look for it in this column over here. So the third column, and you're going to watch out for the EAX register because we need to figure out what's in there. So we see that the EAX register is only interacted with once in this code. So in this instruction here, it's instruction 1, 2, 3, 4, 5, 6. We see that the EAX register has the hex value hex 30 moved into it, and hex 30 should be 48 because it's hex 30 and 3 would be 3 times 16. But let's go ahead and so what is 3 times 16 then? Sorry, what is that in decimal base? So let's make up our little flag. So the flag is going to be picoctf, and then we're going to put in the value of the EAX register in decimal in the center of the curly braces here. So that's going to be the number 48. And let's go ahead and copy this flag. So remember that whenever we submit a picoctf flag, it has to be wrapped with the flag wrapper, which is picoctf, and then the value inside the curly braces. So let's copy that. And I might as well put it in the chat as well, just in case you just want to copy and paste. Let's go back to the challenge. And in the challenge, BitOASM1, at the bottom here in the flag submission field, we're going to paste in our value for EAX. Let's submit the flag. And we're done. Great. Okay, we got ads running on Twitch, and while ads run on Twitch, we'll also do one for YouTube. And what we're going to do is we're going to take a little break while the ads run so nobody misses anything. And we're going to go ahead and watch some bird videos. How about this bird video? So most of the bird videos feature my favorite bird, which are these stellar jays. They love eating these peanuts. And I'm just going to take a little water break. I'll be back in just a moment or two. But it's actually pretty rare that you see the stellar jays hanging around for this long. They usually pick up their peanuts and they jet off. But sometimes they hang around, and it's really fun to watch them interact with each other. Okay, let's put the birds away and let's get ready to continue on with our lesson. Okay, so the next challenge that we're going to be doing today is we're going to be doing the BitOASM 2 challenge. So in this next challenge, we're going to learn a little bit more about assembly instructions and how they're laid out. And we can access the challenge from this link over here. Can I not copy? Okay, I can copy the entire thing. All right, so the link will be in the chat. Let's go ahead and navigate there. Okay, so this is the BitOASM 2 challenge on picoctf. It is a medium level challenge in the reverse engineering category. And the description says, can you figure out what is in the EAX register? So once again, we have to take a look at the disassembly instructions and figure out what is in the EAX register. So put your answer in the Pico CTF flag format. Once again, we have to do the flag wrapper. And once again, we have to make sure that the answer is going to be in decimal or base 10. So even if we see that the value is in hexadecimal, we have to convert the hexadecimal to regular decimal before we can submit it. And we've got a little link. So the link is over here, and we can right-click and copy the link, and then go over to our web shell. So in the web shell, well, we're done with this file. We're going to quit out of here. And let me delete the file from the previous challenge. So after we do that, let's go ahead and download the file for the new challenge. I'm going to paste in the command, and then we're going to download the file. So for everybody who's who just wants to copy and paste, I will also provide the command to download the file in the chat. Okay, so after we've downloaded the file, we're going to see that the disassembler dump 0_b is going to be in our directory here. We can go ahead and let's use the nano text editor to take a look at the file. So remember that when you start typing in the name of the file, you can autocomplete the name by hitting the tab button, just like this. Okay, so let me go ahead and center the instructions here so we can better take a look at what's going on. Okay, so these are mostly the same instructions that we saw previously. Actually, these are exactly the same instructions that we saw previously. There's the NBR64 instruction and the RET instruction that are going to bookend the instructions here. We have the push instruction, the pop instruction, and we've got a bunch of move instructions. But there's something that we need to pay attention to for this particular challenge. And let's talk about that now. So in this challenge, we're going to be talking about variable memory locations. So if you know some basics about programming, you'll know that variables are basically little storage locations where you can put in different values. So in the case of assembly, there are also variable memory locations. And they're usually named all sorts of different things. And in this case, these let's see, we've got two different memory locations here. One called keyword PTR, and then in the square brackets, RBP minus hex 20. And there's another one called dword PTR, RBP minus hex 4. So for this challenge, it's important to understand how variables are saved in x86 assembly. When a program starts, memory locations will be allocated for variables, and we can move data through those variable locations just like any other memory registers. So in this case, we can use the move instruction, and we can move the data into these variable memory locations over here. So the name of the variable memory location is dword PTR square brackets RBP minus hex 4, and the hex value 9FE1A is moved into that location. So the other thing that we need to pay attention to is that the value okay, let's go back to the challenge. So over here, this memory location, it's going to take the hex value of this, because this is the move instruction, and it's moving this hex value over here into this memory location. So dword PTR RBP hex 4, and this is the value here, hex 9FE1A. So offhand, I don't know what the value of this is, so we can go ahead and translate this. So we could use some web apps like hex to decimal. It's probably going to take us to rapid tables. Okay, this is a popular website where we can do conversions. So we can translate hexadecimal to decimal. We're going to paste in a hex number, and we're going to convert it. So this number converted from hexadecimal into decimal is this. So this is the answer. Why do we know this is the answer? Well, let's take a look. So first of all, this value over here is moved into the variable dword ptr rbp minus hex 4, and then the next instruction after that, we move the value in dword ptr rbp hex 4 into the EAX register, and the goal of the challenge is to figure out what is in the EAX register. So it is this hex number over here. Let me copy that number one more time because okay. So let's go ahead and paste in that number, and we're going to wrap the picoctf flag wrapper around it. Remember that the flag wrapper is going to be, the answer is going to be around these curly braces, and we have to start the flag off with picoctf like this. So I will paste this into chat, and we can submit this as the answer. Okay, so we're going to go back to the challenge, and in the challenge here, we're going to paste in the answer and submit the flag. Okay, and we've just completed the challenge. So everybody, if there's some detail about what we did in the challenge that you don't quite understand, then please don't hesitate to ask the question in chat, because there are no bad questions. The number one thing you have to, if you want to learn, the most important thing to understand is that you have to ask questions in order to get answers. And if you're not brave enough to ask the questions, then it can be difficult to get the answers. All right, so let's go ahead and do the next challenge. So the next challenge is the BITO ASM 3 challenge. So let's go ahead and move over there. I will copy the link. Here you go. So let's go ahead and paste this into picoctf website. Okay, so this is the BITO ASM 3 challenge. We're going to be learning about more concepts in assembly through working through this challenge. So here, the description asks, can you figure out what the EAX register, what is in the EAX register? So this is exactly the same as the other challenges, only there are going to be some complications that go on in the instructions. So let's go ahead and copy the link that has the disassembly instructions. After that, we're going to go back to our web shell, and we're just going to get out of here and delete the file from the last challenge. After that, we're going to use the wget command and download the new file. And if you're wondering what command we're using, it's this one right here, just in case you just want to do some copy paste. There you go. Okay, so let's go ahead and take a look at the instructions for this challenge here. It's going to use nano. So dis, press tab, autocomplete the file name. Okay, so there are quite a few more instructions in this challenge here. Let's go ahead and do some formatting so it looks nice and tidy when we do our analysis. Whoops. CypherFreak says, quick tip, just echo 0 hex something something in the terminal, get decimal back. Oh, that's very handy. Yeah. Yeah, I should do that. I should do that. Thank you. I'll try that out the next time we have got some hexadecimal stuff. which is probably going to be very soon. Thank you for that tip, CypherFreak. Okay, let's see if we can... Okay, so we've got a full page of instructions here. So what are we doing here? So most of the time we can ignore a lot of instructions unless they're actually interacting with something we want to pay attention to. And remember, in these challenges, we only need to pay attention to what is in the EAX register. And there's a bunch of stuff that's happening to the EAX register over here. So before we do that, we're going to be talking about a few new instructions that have been added to the mix here. And let's do that first. So the first new instruction that we're going to be taking a look at is the imul instruction over here. And the imul instruction multiplies whatever value is in the first operand by the value in the second operand. So in this case, the first operand is EAX. So whatever information is in the EAX register is going to be multiplied by whatever is in the second operand here, which is the value which is in the dword ptr rbp minus hex 8 variable over here. So we don't know what this is, and we actually don't know what's in the EAX right now. So we're gonna have to do some we're gonna have to keep track of some values before we can get the answer here. All right. So the other instruction that is new for this exercise is the add instruction. So the add instruction is not very complicated. The add instruction adds whatever value is in the first operand by the value in the second operand. So because we're adding, it doesn't really matter what is being added to what, because the value is going to be the same nonetheless. Actually, wait, that's not true. That's not true, because sometimes we're dealing with negative numbers. But anyways, the value that is in the second operand here is going to be put into whatever is already in the EAX register. So we've got a hex value over here. It's going to be added to EAX. That's what's happening with the add operation. So let's go ahead and figure out what the answer is for the challenge. Let's go over to the web shell, and what do we need to pay attention to here? So we need to we see that the EAX register is interacting with the dword ptr variables, so rbp minus hex c and rbp minus hex 8. So we need to pay attention to those two. Let's see. So what's happening over so let's figure out what is in this variable first. So rbp minus hex c. So hex c, we see here that there's a mover operation, and they're putting this value into rbp minus hex c, which is this thing. So this hex over here, let's go ahead and do some math. So we can do some math. Let's try out what CypherFreak was suggesting over here. So echo, and we're going to put in our hex value in the center there. Did I do something wrong? Oh, okay. I think I need to put the hash symbol at the end here. No? I must be doing something. I must be doing the command incorrectly. But we can also just copy this, and we can do our translation online. And let's just go ahead. I think this is the same hex number as before. So it's going to be this decimal number here. So let's go ahead and keep track of that. Okay. So the $sign first. Okay, let me go ahead and try that. So let's see, $sign in front of this, right? Yeah. Oh, okay. So here we get rid of. All right, it worked. Okay, so if we echo and then $sign and then between these double parentheses, whatever hex value we get, we can get the decimal value. That's awesome. That's awesome. Thank you very much, Cypher Freak, for letting us know about that. So let me paste in. Yeah, that's the same value. Okay, so this is the value for the first variable. So let's keep track of that. So let's see. So where is it? Over here? Yeah. Okay. So let's go ahead and put this in the place of the hex. So we're going to put into RBP minus hex C this this big number here, and then we're going to move into RBP minus hex 8. We're going to put in hex 4. So hex 4 and decimal 4 are the same, so this is the number 4. And what's going to happen next? So the next instruction is going to be EAX. We're going to move into the EAX whatever is in RBP minus hex C. So hex C is this number here. So we can go ahead and replace this with the decimal number. So this is the decimal number. Okay. So, and then the next one is to multiply. So we're going to multiply this number, which is in EAX, by whatever is in RBP minus hex 8. So RBP minus hex 8 is the number 4. So we're just going to do multiplication. It's going to be this number, and we're going to multiply it by the number 4. Okay. So the next thing is we're going to add. So okay, let's do the math. Let me go ahead and do some math over here. Echo, and let's just do the multiplication. So I think it's just star for multiply. Yeah, okay. So this number multiplied by this number is this number right here. Let's go ahead and keep track of this. So to anybody who's watching at home, math is not my strong suit. I'm very bad at math. So that's why I use machines to do math for me. Okay. So this is the result over here. And then the next thing is we add to AAX this hex number. So let me go ahead and, whoops, copy, and we're going to add to EAX this hex number. So let me get the translation for this hex number. So we're going to echo this hex number. Okay, so this is the hex number 501. So 501 in decimal. So we're just going to add oops, 501. So we're going to add 501, and what is this thing plus 501? Let's figure that out. So yeah, you can use the terminal to do math for you. It's very convenient. Okay, so we've got this. This should be the answer then. Okay, so we add to EAX 501, which is equal to this. So EAX should have this value in there right now. Then we move into the -4 variable, the value of EAX, and then into EAX we move. So I don't know why this is done like this, but we're basically putting EAX into the RBP minus hex 4 variable, and then we move the variable into EAX. So it should be the same. Anyways, this is the answer we have for the challenge. So let's go ahead and put our flag wrapper around it. So it's going to be, I'm going to put it between these curly braces, and we're going to do pico ctf, And let's go ahead and submit this as the answer for the challenge. Okay. CypherFreak says also likes to use computers to do math. Yeah. Okay, so let's go ahead and submit this as the answer for BitO ASM3. Paste that in, submit the flag. And oh, the suspense is killing me. So if this is not correct, then I'm going to have to re-examine what we've been doing. Okay, the server didn't respond. Let's submit the flag again. So sometimes the PicoCTF server doesn't accept your input. You're just going to have to keep on doing the same thing until it works. Okay, so that was the answer. I was afraid that my math was wrong. Sometimes that does happen. Okay, let's go ahead and solve the, let's do the last challenge that we're going to be doing today. We're going to be introduced to a couple of new instructions, and we're going to be keeping track of some other fun numbers. Let's go ahead and do that. Okay, so we're going to do the BitO ASM4 challenge. This is the last challenge we're going to be doing today. So let's go ahead and access the challenge. So while that's loading up, I'm going to get out of the file here and delete the file. Okay, so it looks like it didn't load up. So I'm going to try accessing the challenge again. Okay, so this is BitO ASM4. This is exactly the same as all the other BitO ASM challenges. So I'm just going to grab the link to download the file, and then in the web shell, I'm going to download the file using wget. Paste it in, download the file. So if you just want to copy and paste my command, then you can use this one. Okay, so we've got the last file over here. Let's go ahead and load it up in the Nano text editor. Okay, so let me make this a little more centered. So there are, I think, 4 new instructions that we need to pay attention to for this exercise. We're going to go over those first before we solve the challenge. So let's go ahead and take a look at the presentation. Okay, so we're going to notice some new instructions here. The first one is going to be the CMP instruction. So CMP stands for compare, and the CMP instruction is going to compare the first operand against the second operand, and it's going to return either equal, less than, or greater than. So this is basically how we do if conditions inside of assembly language. So if something is greater than something, if something is less than something, then we're going to do something else. So the CMP instruction is combined with a jump instruction over here. So the next instruction we're going to take a look at is the JLE instruction. So the JLE instruction moves program execution to the indicated memory address if the previous CMP instruction returned less than or equal. Thank you very much for following on Twitch, Caro Bube. Anyways, let's give you a fun hack the planet. You are now a hacker frog.
Hack the planet! Hack the planet! Shut up and get in the...
So JLE is going to move the program execution to a particular location. So the memory location it indicates is this one over here, main plus 37. And the next instruction we're going to take a look at is the sub instruction. So sub stands for subtract. Caro Bube says, hey ho, hello, nice to see you here. and how are you doing? I hope you are enjoying our lesson on reverse engineering. And if anybody has any questions about cybersecurity in general, please feel free to leave it in chat. I like answering questions while I'm doing these lessons, as long as the answering the question doesn't take too long away from the tutorial. Okay, so the next instruction we're taking a look at is the sub instruction. So sub stands for subtract, and the sub instruction subtracts the number in the second operand from the first operand. So in this case, it's going to be, so the number hex 65 is going to be subtracted from this variable over here, which is RBP minus hex 4. Okay, we got ads coming up in about a minute, but that's okay. We're just going to keep on teaching until the ads come up, and then we're going to take a little break. Okay, so that's the subtract or the sub instruction. The last instruction we're taking a look at is the jump instruction, the JMP instruction. So the JMP instruction moves program execution to the indicated memory location. This is also called an unconditional jump. So unconditional means it's always going to happen, whereas the other jumps, they're conditional. They only happen if there's some sort of result as from a comparison previously. So those are the new instructions we're taking a look at, and let's go ahead and work out the last challenge. Okay, what do we got? So like all the other challenges, we need to figure out what is in the EAX register over here, and we can actually move backwards through, well, maybe moving backwards through the code isn't the best idea, but we should probably keep track of what's happening before we try to solve the challenge. So let's see. So EAX is going to take the value of dword ptr RBP minus hex 4. So we need to pay attention to what is in RBP minus hex 4. And let's see. So the first thing that happens is Karabube says, doing well, thanks, trying to follow the reverse engineering with my poor skills of the topic. Anyways, very interesting. Thank you for sticking around. If there's anything in particular you don't understand, please let us know, and we'll try to explain the best we can. Because I understand that it's frustrating not being able to follow along. Okay, we got an ad running on Twitch. So when ads run on Twitch, we also do an ad on YouTube, and we're going to play a little bird video while the ads are running, so that we don't have people missing stuff while the ads run. How about this bird right here? So this is one of my favorite birds. It's a northern flicker woodpecker. They are all over North America. But I'm going to take a little water break. Ronan, I see you there. I'll talk to you in a bit. I just need to take a little water break. So the funny thing about these northern flicker woodpeckers is that they love eating ants, and you might notice. Well, they're eating peanuts over here, but you'll notice that you might notice that the woodpecker is going to stick out its tongue, and it's got a really long tongue, and the tongue is so long, in fact, that the tongue wraps around the bird's skull when it's not being used. It's actually really it's very interesting. But a lot of woodpeckers are like this. Woodpeckers with really long tongues, they usually wrap their tongues around their skull. Anyways, let's put the birds away and let's continue on with reverse engineering. We're getting close to the end. Okay, so let's go ahead and Ronan, I see you there, and welcome to the stream. Why don't we give you a NyanCAD to welcome you in. Okay, so we see that that the variable RBP minus hex 4, it has this value here in hex. I think we've already seen this value before, but let's go ahead and translate this out. just in case it's a different number. So we can use our terminal here in Linux to translate hexadecimal numbers to decimal numbers. So this is this number. So let's go ahead and substitute that out in the code here. So let's substitute the hex number for the decimal number. And we see another decimal number here as well. We might as well just translate all of these hex numbers ahead of time. Okay, so what's this hex number going to be? This hex number is going to be 10,000. Okay. Copy that. So this is going to be 10,000. Okay, and we also have some other hex here, so it's 65. Not entirely sure what 65 is. Let's go ahead and translate that as well. So hex 65 is 101. Okay, we can remember that. So these two values here are going to be the numbers 101. Caterbug, hello! How's it going? Ask Caterbug, doing okay. We're just finishing up our lesson on reverse engineering. Why don't you have a desert frog? This is the cutest frog in the world. And welcome to the stream, Caterbug. Okay, so we've just translated all of the hex numbers into decimal numbers here. So let's see if this makes more sense. So we're going to move into RBP minus hex 4, this number over here, and then we're going to compare hex 4, which is this big number, 650,000, 654,874. We're going to compare it against this number over here, which is 10,000. Red Sly Fox says, this would be cool to get into eventually. I'm trying to get into web dev first, though. Okay, no problem. I understand that we can't do the stuff that everybody wants to see all the time. But we're going to be doing web app stuff on Wednesday. So please come back on Wednesday. And yeah, we're going to be covering a lot of web app stuff on that day. It is Web App Wednesday. But thank you for stopping by, Red Sly Fox. So it's jumping the sub. Jumping the sub. Jumping the sub. Can you explain what you mean by jumping the sub? Anyways, so we're comparing whatever is in here with 10,000. So 10,000 is less than. So 10,000 is less than 650,000. So that's going to trigger this jump. So the jump less equal is going to go to main 37. Main 37 is main plus 37. This is going to be this instruction here. Let's see. It's going to add to hex 04 the value of 101. So we're going to add 101 to this, which is 600. Let's go ahead and copy this so that we can better understand. So we're going to do some addition here. We're going to add to 650,000 something with 101. So let's go ahead and let's just do the math in the terminal, so that we make sure that it is correct. So let's paste in our math, and this is the result over here. And I think this is our answer. I'm pretty sure this is our answer, but let me copy this. Okay. So the last instruction here, so this is going to be equal to this number here. So this is the new value of the EAX register. The last thing that's going to happen is we're going to move the value of so variable RBP minus hex 4 into EAX. What is in let's see. What is in... Isn't... Wait. Hold on. So is it this? It's going to be either this or this. It's going to be one of these two. I'm pretty sure. Let's try this. So if we're just moving, so if that was a fake out, then it's going to be this value right here. Let's go ahead and try submitting this as the answer. Okay, let's paste in the number. Let's surround it with... Am I missing something? If I'm missing something and you catch it, let me know, because I might be doing my math incorrectly. Okay, let's try this as the answer. But we... Did I do this correctly? So this was jump to 37. If... Oh, wait. Maybe we shouldn't have jumped. So we compare CMP. So the comparison here was done with the comparison here was done with 650,000 against 10,000. So that results. So if we compare those two, then it's greater than. It's okay. So if it's greater than, then this jump doesn't happen. And if it's greater than, this jump doesn't happen, and then we have to subtract. So we have to subtract 101. So whatever we have, we have to subtract 101. So we subtract 101 from this number over here, and then this is going to be our answer. So let's subtract 101. Let me do the math. So this is what I was talking about when I talked about I'm bad at math. Let's do the math, and okay. So this should be the answer now, because the way the code works, we're ignoring the add operation here. The add operation doesn't work. It doesn't add to RBP minus hex 4, so we can ignore this. So this should be the answer here. Let me go ahead and paste the flag in for everybody. Whoops. Oh, I gotta copy that thing again. This over here. Okay, let me so before I provide it to chat, let me just check that this is the answer. Okay, submit the flag. Okay, that was it. All right, everybody, this is the answer. Okay, so what did we learn? We learned a lot about assembly instructions. So let's review the concepts we learned in today's workshop. There's a lot of stuff. So we learned a lot about different instructions inside of assembly. So subtraction, jump, jump less than, comparison. We learned how to do addition and multiplication. We learned about variable memory locations that hold different values. And we learned about some different instructions like the ret instruction, pop, move, and push. So the most important instruction that we learned about today is the move instruction. And the move instruction is basically going to move different values into the memory registers. So for example here, hex 30 is moved into the EAX register. So most of the instructions that you're going to see in assembly kind of revolve around these move instructions. And that is it for today's reverse engineering class. I think we might do reverse engineering once a week. because I need to learn more about reverse engineering so that I can teach it. So I just need to keep one class ahead of the students. Anyways, if you enjoyed the class on this class on reverse engineering, if you are not already following or subscribed on my YouTube and Twitch, go ahead and follow or subscribe, because I would really appreciate it. And that also ensures that you can watch more lessons on cybersecurity from this channel. Okay, let's go ahead and move on to the next piece of content today. And in the next piece of content, we're going to be talking about Linux. We're going to be talking about the Bandit CTF game. And the Bandit CTF game is a very well-known game for learning about Linux and hacking and stuff. This is the link. And while we're doing these levels, we might as well listen to some music, because I hate not having any music in the background. So let me go ahead and put on some music. How about this music from the Valhalla Cyberpunk bartending game? Let's go ahead and turn that on. So as usual, if the music is too loud, please let me know in the chat, and I will try to lower the volume, because music should be in the background and not overwhelming the rest of the stuff. Mainly me talking about these challenges. Okay, so what are we doing today? So we're going to be continuing on with our walkthrough for the Bandit CTF games, and the Bandit CTF games teach us about Linux commands and how to use Linux to solve various little puzzles. We left off on Bandit level 5, and I've got a little GitHub repository where I've been keeping track of all these challenges. So let me give you the link for that. So this is the Bandit game. So if you want to know how to solve a particular level of Bandit, well, all the ones that we've covered so far, you're going to find it over at this GitHub repository. So I might be adding to this as we go on today. The next level is going to be level 5. So, you know one thing I should be including in this file is I should be including the SSH command that we use to log in. So let me add that right now. So we use the SSH command to log into these levels for the Bandit game, and they're located at bandit.labs.overthewire.org on port 2220. I'll just provide this command to chat. Okay, so everybody, one other thing that I'm going to be doing for the Bandit CTF levels is we're going to be using a public resource to access the levels. So not everybody has access to a version of Linux to play the game, so I'm just going to provide a link to a web accessible version of Linux. This is called JS Linux, and it's basically a version of Linux that is accessible from the internet and runs on Java, and you can basically access it using a web browser. So nobody has to worry about not being able to play the game. Okay, so I need to make this a little smaller. Okay, let's try that again. Resize the windows. Okay, so now we're in our JS Linux machine over here. I'm just going to paste in the command. Oh no, that's not the command. It's a RISC-C machine. Yeah, okay, so this is not using the same sort of CPU that we were dealing with previously. So this one is this version of Linux is running on the RISC-C CPU chipset. Well, it's a virtual machine, so it's not using physical hardware. But anyways, it is kind of fun that it's not using x86. Okay, so let's go ahead and let me copy that SSH command. Copy that. Paste it in. and we can go ahead and access the level. So conveniently, we are able to access the Bandit game by using this web-accessible Linux machine. I'm actually kind of surprised that they didn't nerf the network capabilities of these virtual machines that you can access from the internet, because you might be able to do some bad stuff with them if you were so inclined. We are not so inclined. We are good people. Anyways, okay, so I need to do a little YouTube intro and outro. GroutXT says, I had no idea you could SSH from JS Linux. Yeah, this is something that I learned myself relatively recently, but it is very fun. It means that nobody has the excuse that they can't play along with us because they don't have access to any hardware, because the hardware is all on the internet, and everybody has access to the internet. Otherwise, you wouldn't be watching on whatever platform you're watching from, YouTube or Twitch. Okay, let's go ahead and let me do my intro. Okay, everybody, this is a guided walkthrough for Bandit 5 from the Bandit CTF Labs on overthewire.org. So the first thing we need to do is we need to access the level. So we're going to use this command over here, SSH Bandit 5 at bandit.labs.overthewire.org on port 2220. So after we give this command, it's going to ask us if we want to continue connecting. The answer is yes, so just type that in, hit enter, and then we need to supply a password. So remember, everybody, you need to keep track of your passwords. I'm keeping track of my passwords in my GitHub, in my GitHub repository over here. But you all need to keep track of your own passwords. But for people in the live chat, I'll provide the password for you now. Okay, so let's go ahead and paste in the password. Remember, you want to paste in the password and not type it out, because typing it out is not fun. Anyways, go ahead and paste it in and hit enter. And we now have access to the server. So let's go ahead. Oh man, I'm gonna have to do this again. I pressed the, I clicked on the link, and then it booted me out of the virtual machine. Anyways, just give me a second to log back in. Paste that in. Okay, let me get the password. Temporary failure in name resolution. So sometimes the JS Linux machines have problems connecting to different servers, but you just need to be a little bit persistent, and eventually you're going to be able to log in. Okay, so paste in the password, hit enter. Okay, all right, so let's clear the screen. And let's take a look at what is in the directory here. So there's an in here directory. So this is something I haven't been doing, but for each one of these challenges, there's going to be a corresponding level description on the Over the Wire website. So you're going to be able to access it from this link over here. And from that link, you have to click on the sidebar over here, covering the level that we're currently doing. So in this case, we're going from level 5 to level 6, so we're just going to click on that link. So after that, we're going to see that we've got this level goal over here. So it says the password for the next level is stored in a file somewhere under the in here directory and has all of the following properties. So it is human readable, it is 1033 bytes in size, and it's not executable. So when we're talking about how to solve this level, we have to use a very common Linux tool. And let's talk about that now. So on level Bandit 5, we have to use the find command. The find command is used to search for files on the system. It can be used with many different arguments and flags to refine its search parameters. So in this case, The find command allows for search of files and or directories on the file system and matches files in the output according to the criteria provided by the command arguments. So in our case, we're going to be using arguments like type, which searches by file or directory, or size argument, the argument size, which searches for files of a particular size. So we're going to be using this command over here to solve the level. So we're going to use the find command. We're going to use it in the local directory, which is denoted by the dot. We're going to denote the size of the file that we want to return, which is 1033 bytes, which we have to use, where we have to use the C over here to denote bytes in the find command. And then we need to search for files that are not executable. So the exclamation point here means not, and then whatever follows next is what is not going to be. So in this case, it's not executable files. So let's go ahead and give this command to solve the level. So let's go back here. So we're going to move into the in here directory. Remember, you can use the cd command to move between directories. So there's a directory called in here. We move into it by using the cd command, cd in here. So after that, we can take a look at the contents of the directory with the ls command. And we've got a bunch of different directories here. And the point of the exercise here is to use the find command to find a particular file, because searching through these directories manually is going to be a big pain. So that's why we use the find command. So let's go ahead and use it. So the command is called find, and then we need to specify a place to search. So we're going to specify this directory. And this directory, the directory we're currently in Linux, is denoted by the dot over here. The next thing we need to do is we need to specify the size of the file. So we're just going to do -size, and then we're going to have to provide the size, which is 1033. And when we use the find command, we have to use bytes, and bytes are denoted by the C over here. Why is it C? I'm not sure, but that's how it goes. The last thing we need to do is we need to specify that the file is not executable, so it's going to be not. So in computing terms, the exclamation point can very often mean not something. So in this case, it's not executable. Okay, so let me copy this command. Let me copy this command. Let me... Okay. Are we having troubles? Let me type this command into the chat so that you can all use it. There you go. Okay, and let's go ahead and execute the command. So when we execute the command, we only get one file in the output over here. So the file over here is in the maybe here 7 directory, and the file is called .file2. So that's a bit, that's not exactly what we want to see, but it's okay. We're going to copy the file path. So we're just going to highlight it and we're going to copy it. Then we're going to cat out this file in order to read the flag. So it's going to be cat and then paste in the file path. Once we do that, we're going to get this result over here. So this is the password for the next level. So to everybody in chat, this is the password for Bandit 6. Okay, so the last thing we need to do to finish the level is to exit out of the level. Remember to copy the password and to keep it safe, because we're going to be using it for the next level. So before we finish the level, we need to exit from the server. If we haven't exited out of the server, we're not finished. So we're successfully logged out when instead of the prompt bandit5 at bandit, we instead see something else. So root at localhost if you're using the JS Linux machine. Alright, So everybody, let's talk about how we solve the level and then complete this this walkthrough. Okay, so everybody, so we've solved the level by using the find command to locate the file, then read it. So we use the find command with these particular arguments here to find a file that is size 1033 bytes and is non-executable. So after that, we found a file, and then we copied the file path and then used the cat command to read the file to finish the level. Alright, so that was a guided walkthrough for Bandit 5 from the Bandit CTF Labs on overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Karo Bube says, I'm out for today, need to sleep, see you next days. Thank you very much for coming on by, Karo Bube, and let's have a Hack the Planet to see you out.
Hack the planet! Hack the planet! Shut up again!
Okay, everybody, we're not finished. I just need to record my outro for my YouTube videos. I'm going to turn all of these guided walkthroughs into YouTube videos eventually. Thank you very much for your patience. Okay, let's move on to the next level then. So let me go ahead and pull up the next level. This is going to be level number 6. Okay. Let me grab that password. Hold on. Alright, everybody. This is a guided walkthrough for the Bandit 6 level from the Bandit Labs over at overthewire.org. So the first thing we need to do when we do any of these levels is we need to log in using SSH. So we're just going to use our up and down arrow keys to access the terminal history, and we can go ahead and access any of our previous commands over here. We're going to edit our command so that instead of Bandit 5, it now says Bandit 6, and then we're going to log in. Okay, so we're asked for the password for Bandit 6. Remember, you have to keep track of your own passwords, and you definitely want to paste in the password, so we can right-click and then paste, and then hit enter to log into the level. Okay, so we're now in the Bandit server, and it looks like there's nothing inside this directory. So what are we supposed to do? There's an ad running on Twitch right now. So while the ads run on Twitch, we're gonna run an ad on YouTube, and then we're going to stop until the ads are over, because we don't want anybody to miss any of this hack in action. Let's go ahead and put on a bird video. How about the happy birds? I love watching the happy birds because the happy birds don't fight with each other. And let me take a little water break. I'll be back in a couple of moments. So these are some hatchlings. Well, they're not supposed to call them hatchlings. I think these are juvenile birds. So they're juvenile little sparrows, and you can tell that they're juvenile sparrows because they've got very short tail feathers, and the colors of their mouths are also a little bit different. You can also tell that they're juveniles because they're not fighting with each other. Other sparrows do not share food very well, and they'll usually start attacking each other if they try to get into close proximity to eat stuff like this. Anyways, let's put the birds away. That was one of our sparrow facts for today, and let's continue on. Okay, so what we need to do is we need to go over to the Bandit level goals over here, and we're just going to go over to this page over here, and we need to go over to Bandit level 6 to level 7. So level 6 to level 7, let's click on this link. And this is the description for the level. So the level goal says, the password for the next level is stored somewhere on the server and has all of the following properties. It's owned by user Bandit7, it's owned by group Bandit6, and it's 33 bytes in size. So this is another level where we need to use the find command, but we're using the find command in a slightly different way, and let's talk about how this is going to be different for this level. So this time the find command is going to be a little bit more complicated, but that's okay. The great thing about the find command is that it can be used to search for very specific files, and this is how it's going to go. So we're going to use the find command, and then number 2, we're going to use it on the location to be searched. In this case, it's the entire file system. So in Linux, if you want to refer to the entire file system, you can use the slash by itself, and that means, yeah, everything. The next one is the type of file to be returned, either a file or directory, and in this case it's type F. Type F means files only, not directories. The next one is, let's see, the file or directory user's ownership. So this means that the file should only be owned by the user Bandit7. And the next one is the group. So the file or directory group ownership, and in this case it's going to be owned by the Bandit6 user. And the last thing that we're specifying here is the size of the file. And remember, we can use -size to indicate a file size. We're looking for a file that is 33 bytes, so 33C in the code that the find command likes to use. So the last thing that we're including here is 2 greater than /dev/null, and this is a very special part of the command, and what this means is that all of the error output, which is the number 2 is standard error inside of Linux, and we're going to redirect that with the greater than sign into the dev null device. The dev null device is basically a device which is empty, and what this means is that any error messages that we would normally see are going to be hidden from us, because we're redirecting all the error messages into the void, basically, or into the garbage can. Let's go ahead and use this very long command. First of all, I'm going to just type it into the chat, just so that I can copy it for later. Okay, so I've pasted it into the chat, and let's go ahead and run this command on the server. So here, let's go ahead and paste in the command. Okay, I don't think I've made any spelling errors here. Remember, everybody, if you can't spell correctly, you can't hack, and that would be very sad. So let's run the command. And when we run the command, we only get one file in the output. So this is going to be the Bandit7 password. I guess it's kind of obvious because the file is called Bandit7 password. Let's go ahead and copy this and then read it. So just going to copy the file path. Then we're going to cat space and then paste in the file path here. Then we're going to read it. And this is the password for the next level. Okay, so remember, if we don't exit from the level, we're not finished the level. So the last thing we need to do is we need to exit from the level, and when we see the logout, that means we're finished the level. Alright, so before we finish up, let's go ahead and do a little after action report over at GitHub. So this is the Bandit6 level, and the method of solve in this case is use the find command again to locate the file. So we used the find command, and with a bunch of different arguments here to find the file. In particular, we searched the entire file system for files only, for files owned by the user Bandit7, and files owned by the user group Bandit 6. The size of the file is going to be 33 bytes. And all of the error messages we're going to put into the dev null device. Okay, so after that we got a file location, and then we used the cat command to read the file. Alright, so everybody, that was a guided walkthrough for the Bandit 6 level from the Bandit CTF Labs located on overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Alright, so let's go ahead and start the next level. I hope everybody's enjoying these demonstrations. If you have any questions about any of the commands we're using, or if for some reason something in the command seems a little bit weird, and you want to ask why it is that we have to do it this way, let us know in the chat, and I'll try to answer your questions as best I can. Like I said, I don't want anybody to feel lost while we're doing these demonstrations, and I want us still to be able to learn together. Okay, so let's start the next challenge. Okay everybody, this is a guided walkthrough for Bandit level 7 from the Bandit CTF Labs on overthewire.org. If the first thing we need to do is we need to access the level using the SSH command. So we can go ahead and use the command history and then edit and modify the command from Bandit 6 to Bandit 7, and then we can issue the command. After that, it's going to ask us for the password. Remember everybody, you need to keep track of your own passwords, and you definitely don't want to have to do all of the levels in a row if you forget what the password is. So in this case, we're going to paste in the password, and then we're going to be in the level. Okay, let's go ahead and take a look at, okay, there's a data.txt file. So what's going on here? Let's go ahead and read the level description, and then we can figure out what we need to do. So we're going to go over to the level description for level 7 to level 8 over on the webpage. And if you're wondering which webpage we're looking at, it's this one. So the level goal over here says the password for the next level is stored in the file data.txt next to the word millionth. So let me demonstrate what is going on here. So there's this data.txt file. I'm going to run the head command to get just the first 20 lines of the file. The file is very, very long. Very, very long, very, very large. And it's got a bunch of words and then potential passwords over here. What we need to do is we need to find the line in the file that has the word millionth, and then we need to copy whatever password string is beside that word, and that's going to be the password for the next level. So how are we going to do this? Let me explain. There's a very useful Linux command that we need to use, and it's the grep command. So the grep command is going to search within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases inside of files. And when you use a lot of Linux, people are going to talk about grepping something or grepping out something, and that basically means to use the grep command to search for particular words or phrases. So the syntax for using the grep command is as follows. So the first thing we need to do is provide the command itself, which is grep, and the second thing we need to provide is the pattern to search for in the file or directory, which in this case is the word millionth. The third thing we need to do is provide a file to be searched. So in this case, it's going to be the data.txt file. So it's not super complicated, but let's go ahead and do this inside of our level here. So it's going to be, so it's the grep command. The second thing we need to provide is the pattern. So the pattern is millionth. So that's the word we need to search for in the data.txt file. So it's just grep space millionth space data.txt. So when we run the command, we're going to see that we're going to output the word millionth and everything else that is on that line. So on the line is this. So this is the password for the next level. Let's go ahead and copy this. Okay, so before we finish, let's go ahead and do a little after action report for how we finish this level. So this is level 8. Okay, so the method of solve, in this case, locate the line in the file. Oh, this is supposed to be level 7, right? Okay. Okay, so the method of solve is use the grep command to locate the line in the file that contains the word millionth. In this case, we use the grep command to grep out the word millionth and everything else that is on that line. And everything else that is on that line is the password. So alright, everybody, this was a guided walkthrough for the Bandit level 7 that is part of the Bandit CTF game on overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. But we're not leaving. We've still got a couple of levels that we're going to be covering today, and we're going to be going up until the top of the next hour. So we got about 20 minutes, 19 minutes, and hopefully we can cover the next 1, 2, 3 levels. Okay, let's go ahead and march on. I forgot to exit from the previous level. Hope everybody... So anyways, remember to exit from the level, because if you try to log into the next level while you're already logged in, you're not going to have a good time. Okay. Alright everybody, this is a guided walkthrough for the Bandit 8 level from the Bandit CTF Labs on overthewire.org. Let's go ahead and use SSH to log in. Okay, it's going to ask us for the password here, so we're just going to paste in the password and hit the enter key, and that's going to log us in. Oh, I keep on clicking on that link. Okay, everybody, don't click on the link when you log into the level, otherwise it's going to take you away from your terminal, and that's not great. Okay, so SSH Bandit 8 at bandit.labs.overthewire.org, port 8220. Let me copy the password one more time. Paste in the password. Okay, so in this level we've got another data.txt file. So let's go ahead and go over to the level goals page and take a look at what we need to do to finish this level. So this is going to be on level 8 to level 9. And in the level goal it states the password for the next level is stored in the file data.txt and is the only line of text that occurs only once. So let's go ahead and take a look at what's going on here. So we see we've got this data.txt file, and it's got a lot of let me give a sample of what is in this file. So we're just going to print out the first 20 lines with the head command over here, and it's just a bunch of different potential password strings over here. What we need to do is we need to figure out which one of these lines occurs only once in this output, and that's going to be the password for the next level. So let me explain what commands we're going to be doing to solve this level. There are a couple of new concepts we're going to be going over in this level as well, so let's talk about it. So in Bandit 8, we need to use the sort command. So the sort command takes all the lines contained within a given file and returns them in alphabetical or numerical order. So it's basically going to sort all the lines in your file by alphanumerically. but we have to combine this sort command with another command to get our password. And so the sort command is very simple to use. It's just the command itself and then the input to be sorted. In this case, it's going to be the data.txt file. So we're going to combine the sort command with the unique command. So the unique command takes all the lines in a file and removes any lines with identical contents to the one above it. So basically, if there are a bunch of lines that are the same, it's going to delete all the identical lines. So this command is very useful for removing consecutive blank lines in a given file, but we can also combine the unique command with the sort command to achieve some specific goals. So how do we use the unique command? So we're going to be using it like this. So number one is going to be the command itself, unique, and then number two, we're going to use the count flag. So if we use unique with this special flag here, it's going to print out the number of times a specific string is encountered in the file. It's going to number the lines. So the third thing we need to provide is the file to be processed, which is the data.txt file. So another thing we're going to do in this level is we're going to do something called command piping. So if you're not familiar with command piping from using other command line interfaces, command piping is it's a very useful technique, and I'll just talk about what it does. So in Linux, command piping is the process of passing the output of one command into the input of a second command. So if we've got, say we've got a file over here. Let's just make a test file. Echo, this is a test file, and we're going to put it into a file called test.txt. So what we want to do here is I'm going to read the test.txt file, and what am I going to do to it? I'm going to... What can I do to this output? Actually, no. What we can do is this. We're going to echo out a message. This is a test message, and we're going to do something to it. We're going to... I'm doing this off the cuff, but we're going to transform it using base64 encoding, say. So we can use base64, we can just run that and then pipe into base64. So basically, this message over here is going to be encoded using base64, and we're passing this argument over here to base64 by using this pipe character. So in this case, base64 is going to run on the output of this. So this is a test message, and it outputs this this encoded string over here. I'm actually doing this out of order because we're going to be teaching the base64 command in a couple of levels. Anyways, let's go back to command piping over here. So command piping is the process of passing the output of one command into the input of a second command. This is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. So in this level, we're going to sort all of the lines in data.txt, and then we're going to take those sorted lines and we're going to get only the unique ones. So in this case, this is the command we're going to use. So we're going to do the sort command on data.txt, and then we're going to supply the pipe. So whatever is output by the sort command is going to be fed into the unique command, and then we're going to run -c, which is going to number the number of times the line occurs in the file. So let's go ahead and try this out. So over here, we've got data.txt. We're going to run the sort command, and let's just see what happens if we just run the sort command by itself. Whoops. we need to spell correctly. So we see all of these lines over here, and they've all been sorted, but we don't know how many times they occur inside the file. So what we need to do is we need to chain the command together with the unique command. So let's go ahead and do that. So we're going to sort data.txt, but we're also going to supply the pipe character over here. And to anybody who doesn't know, the pipe character is the shifted version of the backslash. So if you can locate the backslash on your keyboard, the pipe character is going to be the shifted version of that. So after that, we're going to give the unique command with the count. So if we run this together, then we get the number of times each one of these strings occurs. And remember, we only want to get the string that happens once. What we can do is we can actually just scroll up, and we can see that this string over here occurs only once, but we can actually chain more than one command together. And let me demonstrate that. Let me clear the screen. So we're going to run sort on data.txt. We're going to pipe it into unique to get the number of times each one of these strings occurs, but we're going to pipe it into another sort command. And in this case, the lowest number of lines is going to come at the bottom of the output. So let's go ahead and see what happens when we run this. So we see here that the lowest number of lines is at the bottom, and it's this line right here, and this is going to be the password for the next level. So if you're keeping track, that's the password for the next level. So remember, we're not finished with the level until we exit. So we give the exit command, and now we're done. Okay, so let's talk a little bit about how we solve this level before we finish off. Okay, so in this level, the method of solve is to locate the line in the file that occurs only once. We use the sort command to organize the data into groups, and then use the unique command with the -c flag to help with the number of times each line appears in the file, and then we use the sort command again to return the least occurring lines at the end of the list. We used command piping to do this, and that's how we solved the level. Alright, so everybody, this was a guided walkthrough for the Bandit 8 level from the Bandit Labs from overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out! Alright, so I need to write up the little GitHub file for the next level. So give me just a second so that I can edit that file. CypherFreak says, "Powerful stuff, man." Well, everybody has to learn. Everybody who wants to learn Linux has to learn somewhere, and there's something. Sick in Mind says, "Buy YouTube, buy YouTube." Okay, but yeah. So if you wanna learn Linux, you gotta learn somewhere. Doing these fun little exercises helps you learn about Linux. Then everything is good. Let's go ahead and make the new file. This is gonna be level 9. Level 09.md. Let's paste in. Let me get the password for the level. Second Mind says, "I don't know. I figured you were ending a segment there for a short YouTube video on that one specific." Oh, yeah, that's exactly what I was doing. Please don't think that I'm ending my live stream right now. That's not what's happening. It's just that I have to record all of this stuff for YouTube. Anyways, let's go ahead and let's go ahead and start the next level. CypherFreak says, "I'm referring to what you could do according to the man pages." What I could do according to the man pages? Are we talking about the powerful stuff? Or are we talking about one command in particular. All right, let's do one more level. We'll do one more level, and then that's gonna take us to like the top of the hour. Okay, Cypher Freak says we could do a less and grep. Could we? I mean, I've never tried that way, but of course, you know, when we're talking about Linux, we can solve a problem in a lot of different ways. Just everything. Oh, okay. I'm trying to not make the videos like super long. Trying to get to the point. Hopefully, it makes sense. But let's go ahead and do the last level for today. All right, so everybody, this is a guided walkthrough for the Bandit 9 level from the Bandit CTF Labs on overthewire.org. The first thing we need to do is we need to log into the level. It's going to ask for a password. Remember, everybody, keep your passwords handy and then paste in the password. Okay, so what is going on in this level? Let's take a look. So we've got a data.txt file again, and we're just going to go over to the level goals page to figure out what we need to do for this level. So this is going to be level 9 to level 10. All right, so the level goal here says the password for the next level is stored in the file data.txt in one of the few human-readable strings, preceded by several equal sign characters. So what are we talking about in this level? Let's talk about the concept of binary data in text strings. So in general, the contents of most computer files can be roughly divided into two types. So either binary data, which is intended to be read by software or by computers, and text strings, which are intended to be read by humans. So data in text are the two data types, or the two types of things you can find in the files. So if you read a binary file using a standard command, you're not going to be able to read what comes out. So for example, we're reading a file inside of our Windows machine here, and it's not something we can read because it's not intended to be read by people. So this is where the strings command comes into play. And the strings command is used to return human-readable text from files. It is often used to find text inside of files that contain both text and binary data. So sometimes there are, in most data files, you'll also see little strings of text, and we've got ads running on Twitch. When ads run on Twitch, we also do an ad on YouTube, and then we can watch a little video. How about this little video? It's got a little bird bath. We're going to be waiting out the ads on Twitch so that we don't have people missing any of the lesson. I'll be back in a minute, but in the meantime, enjoy the birds. Here's a bird. I think this video gets a little better over here. Yeah. It's fun watching the birds have their little bath. It's you know, because they're splish splashing in the water. But yeah, birds have to be really careful when they come down for a bath because they have to watch out for predators. So other birds or cats or squirrels or whatever. Birds have to watch out for themselves, whatever they're doing, at all times of day. Anyways, let's put the birds away. Let's complete this last level. Okay, so we're going to be using the strings command to read a file that has a lot of binary data, but also has little strings of text. So let's go ahead and do that. So strings is a very easy command to use. You just need to use the command itself, which is called strings, and then the file to extract the strings from, which in this case is going to be the data.txt file. So over here, we've got the data.txt file. Let's just take a look at what is in the first little bit of the data.txt file with the head command. So there's just a bunch of gibberish. So we're going to use the strings command to extract all of the human readable strings out of this, the output of this file. So we're just going to run strings on data.txt. So this is okay. This is okay. We got a bunch of strings, but what we need to do is we need to follow what the level wants us to do, and the level wants us to do this. So one of the few human readable strings preceded by several equal characters over here. So if we want to extract the equal characters within the strings, we need to do command piping. So we're going to use command piping with the grep command. So we're going to use the grep command along with the strings command, and we're going to chain them together with command piping. So here, go ahead and go to the top. Okay, so we're going to run strings on data.txt. Then we're going to do the command pipe, and we're going to use the grep command. So the grep pattern that we're looking for is going to be the equal signs over here. So when we use special characters as part of the grep command, we have to make sure that they're encased in quotes, either single quotes or double quotes. Otherwise, we could have some weird output from the Linux terminal. So after the pattern we're looking for, that's all we need to do. Because we're taking the input for grep from the strings command over here, this is all we need to do. So whatever's going to come out of the strings command, we're going to run the grep command on it afterwards and look for this pattern. So 4 equal signs. Let's run the command. Okay, so this is what we get. So it says the password is this. So because we were able to get the strings out of the file and then grep for the equal signs, we got the password. So let's go ahead and copy this. Everybody keeping track in chat, that's what the password is for next level. Okay, let's write a little after action report over here before we finish the level. So the username was Bandit9, the password was this. The method of solve here was need to use the strings command to output human readable strings from the data.txt file, and use the Divad S. Gouda. Hello, nice to see you here. The shy I'm not the shy cat. I'm not the shy cat. I am the shy hat. But thank you very much. Nice to see you here, Devan. And why don't you have a Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, so, and use the grep command to only return lines with a specific pattern using command piping. Okay, so the command we use is this. So it's going to be strings data.txt grep into command, so pipe into grep for the equal signs, and that's it. Alright everybody, this was a guided walkthrough for Bandit level 9 from the Bandit CTF Labs from overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out! Okay, everybody, we're going to be finishing up with this portion of the live stream because it's been an hour. So what we're going to do is we're going to spend the last 2 hours doing some Linux hacking. So Linux hacking means that we're going to be accessing a Linux machine on the network, and we're going to be hacking against it, and we're going to try to break into the machine, and use privilege escalation techniques to take over the computer. But and the site we're going to be using to do that is Dockerlabs.es. It's a Spanish language website where you can download vulnerable Docker containers with Linux machines and then do hacking against them. What you do is you deploy the Docker containers to your machine, and then you can hack against them. So, if you want to join in, please feel free to do so. And if you want to sit back and watch the magic happen, or to provide some helpful hints for how to hack the system, then you're very welcome to do so. We're going to be doing this exercise over here called WalkingCMS, and something tells me we're going to have to access some web pages and break in through there. What we're going to need to do first is we're going to need to download the machine. So on the Dockerlabs.es website, we're going to download the machine, and then we're going to deploy the Docker container after we download the file. So this is thank you very much for following Sleepy Dude 1 on Twitch. Thank you very much. And why don't you have a Nyan Cat on me? There you go. So everybody, if you have any questions about any of the commands that we're doing, or any of the process that we're doing for hacking this Linux machine, please let us know in the comments or in the chat, and we'll try to explain as best we can. Remember, there are no dumb questions, because we've all been beginners before. And if you have any questions about cybersecurity in general, I'm very happy to answer those questions during our free hacking exercise, which this is our free hacking exercise. Huh. Downloads are mighty slow right now. I'm not too sure why. But anyways. So we should have, let's see, our Docker container is going to land in our downloads directory. And if anybody's wondering what kind of machine I'm using here, I'm using a distribution of Linux called Kali Linux. And Kali Linux is basically, it's a Linux machine with a bunch of security tools installed on it. And it's through using these security tools that we're going to be hacking against the Docker container that has Linux machine. So let's get rid of all the tar files. Oh wait, maybe not get rid of all the tar files. It's going to get rid of some of these. I'm going to do a little bit of cleanup over here, because I've been downloading a lot of this stuff. And I want to make sure that I've got enough space on my computer to run things properly. Huh. It's downloading real slow. I guess we're going to have to wait a little longer. It says like half a minute. But yeah, in the meantime, if anybody has any questions about cybersecurity or how to get into cybersecurity, I know that there are a bunch of people who are trying to get into cybersecurity. You might be watching the live stream. Let us know. Let us know what your history is with technology or like programming, and maybe we can help you out. They say that a watched kettle never boils. This is so painfully slow. Bavlov says, over the wire labs was my final exam for Linux class. Loved it. Oh, nice to see, yeah. No worries, no worries. You know, if you want to do something that's similar to over the wire Bandit, there's another set of Oh, okay. Let me change my music. Hold on. Seem to have run out of music on that list. Let's see. Playlists. Let's switch over to some faster than light because we like to go fast. Okay. So this is from the great space roguelike game called Faster Than Light. It's all about blowing up spaceships, and it's a great little space game. It also has some great music. Okay, what we were doing? We were I was suggesting a site, right? So there's the hackmyvm.eu site over here, and if you don't have an account over here, you can make one. They've got some fun little CTF labs. And let's see. Where are the labs? HMV labs, okay. So they've got these CTF labs. They're very similar to Over the Wire Bandit. And this one over here is one that I went over on stream before. It's called the Venus Labs. And the process for playing these games is very similar to Over the Wire. Let me leave the link over here. Sleepy Dude says FTL music, awesome, yeah. Okay, let's go ahead and do some hacking. So we downloaded this file over here, WalkingCMS.zip. We're just going to use the unzip command to extract all the files. So if you're interested, I also have a playlist over here. Let's see, on my YouTube. So the YouTube, this has been a very, very long running series that I've been doing. Hack my VM. Let's see, Venus. Yeah, I've got a big old playlist. I've currently got 39 videos on here. There are 50 levels in total for these labs. Bavlov says, I've been trying to get back into reverse engineering. I've been spending all my time writing C stuff lately. Oh, that's awesome, yeah. So reverse engineering, well, a lot of the reverse engineering CTF challenges involve looking at code that was written in C. So yeah, learning how to write C code would be very, very helpful. So learning how to write C code and how to look at assembly instructions. We actually covered a lot of assembly stuff earlier today. But let's go ahead and get back to the hacking. So we let's see, what is the word? We inflated, is that the correct term? We unzipped this file over here. So autodeploy.sh and walkingcms.tar. What we're going to do is we're going to run the autodeploy.sh script to deploy the Docker container. Bavlov says, I'm going to be lurking. Happy hacking. Happy hacking to you as well, Bavlov. So let's go ahead and... Oh, Bavlov, let me give you something fun to go out on. How about all the things? This is one of the hacker rap anthems.
This one's dedicated to all the hackers. Yo.
Decompressed is the word, says Cypherfreak, or just unzipped. Yeah. You gotta use the right terminology. All the hackers. If you look that up on YouTube, All the Things by Dual Core, you'll find the full version of the song. It's a very good song. It's very, very fun. Okay, so we can, what we need to do is we need to execute the auto deploy script over here. And then we need to run it. So we're going to run autodeploy, and we're going to run it with the tar file over here, walkingcms.tar. And because this is from a Spanish language CTF site, we get some Spanish over here. So, estamos desplegando la máquina vulnerable, espere un momento, and then we get... Is this a file hash? I'm not sure. Well, I mean, it's kind of weird that the file hash is here. Is this some sort of hint for the exercise? I would be very surprised, but maybe we need to reference this later. Anyways, we have an IP address that we need to hack against over here. So the deployed Docker container is going to be at this address here. So we can just copy this, and we can start scanning the machine using Nmap. So Nmap is a program that you can use to determine what ports are open on a remote server. A remote server being any computer that is not your computer on a network. And we're going to give it a bunch of different arguments so that it runs the way we want it to. In this case, we're going to run it very, very fast, which is this argument here, 5 threads. Whatever services we find on the system, we're going to run common scripts and versioning information on it to get extra information. We're going to run the command very verbose, which means we're going to get output before the scan is finished. And we're going to run it on all of the TCP ports with this command over here, -p-. And we're going to get a bunch of information about the machine. So there's only one port open on this container. So the only port that's open on the container is Cypher. Freak says, what do you do after the command? Anything or straight to Nmap? So let's see. So the first thing we need to do is we need to deploy the machine. So after we deploy the machine to our Docker container network, then we can start our hacking. The IP address is given to us in the message over here when we deploy the machine. Then we can go over and do our Nmap scans over here. So in the Nmap scans, we see that there's only port 80 open on the machine, and that's running a web page. So port 80 typically runs the HTTP service, which is unencrypted web pages, and it's running with this software right here, Apache software, and this version number 2.4.57. So aside from that, we need to do some enumeration on the web page. So there are a few different tools we can use for enumeration on web pages. We can use the dirb command. We can use the dirb tool, and dirb is going to run directory busting. What we mean by directory busting is trying to find out what endpoints exist on the target. So if we try to, dirb uses a pretty short word list, and it tries to figure out if any of these words or any of these locations on the word list are present on the system. So in this case, it found these. Oh, there's WordPress. Okay. I guess I shouldn't be surprised. Okay, so one thing that dirb is good at is doing enumeration against WordPress installations. So WordPress is what is known as a CMS, or content management system. It basically lets you set up a website or a blog, and WordPress is one of the most popular content management systems out there. It also happens to run on the PHP programming language, which is kind of well known for having a bunch of security problems. But not to say that any application that's written in PHP has security problems. It's just that PHP is kind of infamous for for the ability to be hacked. Let's just put it that way. Okay, so now that we've found that there is a WordPress installation, let's go ahead and take a look at the web page. So in our web browser, we can go ahead and go to the web page over here. So if we go to the landing page, we see that this is a Debian default page, which means that the website isn't actually here. what we need to do is we need to go to the WordPress website, and we saw that there was a WordPress directory, so we need to navigate over to the WordPress directory. So in here, we're just going to go /WordPress, and okay, so we've got some text. We've got it looks like a little blog. So this is the type of page that we can create with WordPress, and we've got we got index.php, pagina ejemplo. Oh, example page. Example page, I think that's what it says. So we can go to this example page, and I guess there's not too much to look at here, but the most important detail that we should get out of our scans is that this is running a WordPress site. And WordPress is actually, there are specific tools that we can use to scan WordPress sites. Let me demonstrate. So let's just look up, there's a website that a lot of people use when they're learning about cybersecurity and hacking, and it's called HackerFrogs. So the website is located over here. I'll leave the link over here. And we can search for any technology that we want to do hacking against inside of on this page. So let's just say we're looking for WordPress. So there's an article that talks about WordPress. Let's see. Pen testing, web methodology, WordPress. Let's go ahead and go over here. So we've got a lot of information about how to do hacking against WordPress in this article here. I'll just link it below. There you go. But there's one tool that that is very commonly used and to do enumeration against WordPress sites, and the tool is called WP Scan. So let me go ahead and demonstrate. Let me go ahead. WP Scan. Black says, hi, hello, nice to see you here on Twitch. Why don't you have a Hack the Planet? Hack the Planet. There you go.
Hack the planet! Hack the planet! Shut up and get in.
Nice to see you here on Twitch. We're just doing a little Linux hacking exercise. We found a little WordPress installation, and we're currently looking at a challenge from this website right here, Dockerlabs.es. We're looking at the the facile category and the WalkingCMS machine. If you're interested in hacking against this machine yourself, I'll provide the download link over here. There you go. There you go. Okay, let's use WP Scan. So WP Scan, we need to provide a URL. It's been a while since I've used this. Let me see if I can get a cheat sheet. So for any tool that you want to use, so let's say I'm looking for WP Scan, I can search for a cheat sheet, and we can get a bunch of examples for how we use the tool. I guess for WP Scan, we could try this one over here. So enumerate vulnerable plugins, users, vulnerable themes, thumbs, etc., etc. Let's go ahead and use this example over here. So the download file is for the Docker container. So the challenges over at Docker Labs over here are all going to be vulnerable Docker containers that you have to deploy to your network. So after you download the container, you can unzip the file and then use the script that's included with the zip file to deploy the Docker container and then do your hacking. Okay, so we got WP Scan, and then we have to provide a URL. In this case, it's going to be HTTP 172.17.02 WordPress, because that's where the WordPress installation is. Let's follow redirection. Okay, we can't use this. Apparently there's something wrong with the cheat sheet. That's unfortunate. Actually, I think we just need to do it like this. Okay, so we run the WP scan tool, and we find a bunch of stuff already. Okay. So we found some headers that give us information. XML RPC seems to be enabled, so this is a setting inside of WP scan that can be used for some extra enumeration. Let's see, running Linux and yes, running a Linux machine using the Docker tool. Okay, so WordPress README file found. Okay, upload directory has listing enabled. This is not great. Well, this is not great for them. Okay, let's see, what else do we have? WP cron seems to be enabled. WordPress version identified. Okay, so one thing in particular that we need to take note of is some versions of WordPress are vulnerable to different hacks. So we can do some research over here. Search for WordPress with this version here. Okay, so we didn't find anything relevant to this particular version, so we don't get a hit on that. So that's fine, that's fine. Let's go back to the WP scan and see what else is there. So WordPress theme in use is 2022. Okay, so 2022 is kind of old because it's not 2022 anymore. We might be able to find something for this plugin. So there's, oh sorry, it's a theme. WordPress themes can also be vulnerable to different hacks. Okay. We need to, but in order to find a relevant hack for this, we need to get a version number. So we don't know what the version number is. It says the version is out of date. It doesn't tell us what the version number is. Oh wait, version 1.6. Okay. So let's try searching for this with version 1.6 over here. Okay, let's search for that. Okay, we've got ads on Twitch. When there are ads on Twitch, we do ads on YouTube as well. And then we play some bird videos, because we are not... We're not leaving anybody behind. We're not going to be we're not going to have anybody missing out on the action. We're just going to take a little break. We're going to have a little bit of water, and we'll be back in just under a minute. So GroundXT says the readme.txt URL might have the version as well. Yeah, there are lots of places we could look for information. So the important thing that we can do, the most important thing we can do is just basically look around for a bunch of different information on the system. And we can get all sorts of interesting information like configuration settings or like software versions. These are all important things to enumerate in order to do a successful compromise of the system. Okay, let's put the birds away and let's continue. Okay, so we searched for known hacks for this particular software version, or sorry, this particular theme version inside of WordPress, but we didn't find anything. Let's see if we can find something just for version 2022, theme for 2022 in general. So we didn't find anything. Okay, let's go back and see if we can find anything else. Okay, so we're looking for vulnerable plugins. Oh, we've identified a user. So we've got the Mario user over here. So it's confirmed by RSS generator, passive detection. Okay. So we have a username. So if we have a username, we could potentially try to brute force the login for this user. And if we're able to brute force the login for this user, then we could potentially break into the server by using some sort of file upload attack. So let's just add this to our users.txt file. Maybe. Just going to add this to our users.txt file. And we might want to figure out if we can simulate a login to the website. Because if we can simulate a login to the website, then we can do some brute forcing and try to brute force our way into the application. So let's go ahead and do that. Actually, if we want to do that, we should probably start up our Burp Suite program. Thank you very much for following on Twitch. Carrykaon9? Let me know how to pronounce your name, and I will pronounce it correctly. Thank you. Thank you very much for following. You're now a HackerFrog. How about we all remember the Devil's Bedroom?
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
So we're starting up a program called Burp Suite right now. Burp Suite is a web app proxy program, which means that all the web traffic that moves between the web browser and the web browser and the web server is going to be recorded by the Burp Suite proxy over here. And this is a program that is used by professionals to do web app security testing. So we're just going to start up the tool, and then we're going to start up the browser that's attached to Burp Suite. So Burp Suite has its own browser that we can use, and this is it's like any other web browser, except that the traffic that goes through this browser is going to be recorded by Burp Suite, and then we can take a look at the recorded requests after the fact, and then figure out if there are any security flaws. So let's go ahead and access the website. So it's going to be what? 172.17.02 in the WordPress directory. And what we want to do is we want to access the admin page. And I think the admin page is going to be at wp-admin. Okay. So wp-admin. We're going to try to log in as the Mario user, but we don't know their password. So for password, we're just going to do test. We're going to try to log in. Okay. They've got an action for lost password as well. Sometimes the implementation of password recovery for web apps can be vulnerable as well. So in this case, I guess we're going to look for, what is it asking for? Nombre de usuario correo electrónico. So this is, it's looking for an email address, I'm pretty sure. But just in case, I'm going to look this up in Google Translate. Username or email address. Okay, there's a language selector. That's very handy. Thank you for the input for the sharp eye Grout XT. Let's take a look. So, language selector, huh? Okay, so we can change it from Espanol to English United States. Username or mail. Okay, so get new password. So is this going to send an email? If it sends an email, then we can't really take advantage of it. The email cannot be sent. Your site may not be configured to send emails. Get support for resetting your password. That's okay. Usually this is not the way in anyways, but let's go ahead and go back to Burp Suite and then take a look at the login request. So we're going to go from proxy to the HTTP history. We're going to move down to the post request to the WP login endpoint. So this is, yeah, this one right here. Okay, so this is the request that was sent when we tried to log in. We're going to send this to another tool inside of Burp Suite, which is called the repeater. So the repeater, actually, we don't. Do we need to use a repeater? Maybe we don't. That's fine. So the request for login has all this. This is the output over here, and in the response, let me pull this up. So this is the response the web page sent when we tried to log in. So this might seem a little messy over here. What we can do is we can turn this into the web page rendered version of this response, and this is going to give us a lot cleaner output for what happened on this page. So this is just something you can do to make sure that you can understand what's coming back. But we can always go to the request. What we're going to do is we're going to try to log in. We're going to try to brute force this login using the FFUF program. So what we're going to do first is we're going to save this request as a text file. So we're just going to right click and select this button over here, which is called copy to file. We're going to save this request with all the information in here into a file called request.txt. So after that, we're going to minimize Burp Suite and go back to our terminal. In the terminal, we've got request.txt, and this is all the information we need to make this request to try to log into the website. What we're going to do is we're going to try to brute force the password for the Mario user. So we've got our information that we're sending to the web page. And what we need to do is we need to specify what we're going to fuzz. So fuzzing is basically trying to figure out what inputs are valid in a web application. And in this case, we're going to try to fuzz the password. So we use tests in our test login here. We're going to replace that with the word fuzz. So that's going to let the FFUF program know where we're supposed to put our test passwords when we're trying to brute force the login for the website. Let's go ahead and save out this file. And then we're going to run the FFUF program. Simon Dante says fuzzing is live. Yeah, fuzzing is live. Let's go ahead and try to fuzz the password. And there's a very common password list that we use for these type of brute forcing password attacks. And the file is called. And Cyber Dante, nice to see you here. Why don't you have a desert frog? There you go. Welcome to the stream. So the common password list we use when we do these brute forcing attacks is called rocku.txt. Rocku.txt is a leaked list from a long time ago, but it's got the most common 14 million passwords, and it's very commonly used when we do attacks like this. So let's go ahead and see if we can brute force the login for the user here. Okay, so you see here that we're trying to send all of these different passwords to the application, and in response, we're getting this this size of response from the server. What we're going to try to do is we're going to try to figure out if we can get a different size response, and a different size response from these failed attempts over here are probably going to tell us which attempt is valid. So let's go ahead and filter on that response size. So it's FS 8211. So we're not going to see any of these requests unless the response size is not this, which is equal to the failed ones. Oh, wow. Wow. Mario's password is love. That's great. That's great. Okay, so we so we managed to brute force Mario's password. Let's go ahead and log in. Super secure. Yeah, very secure. All right. So I love that. Yeah, I love it too. It's love all over. Okay. Let's go ahead and go back to the application. We're gonna go back. We're gonna go to the what was it? WP admin. WP admin endpoint. We are Mario. We love, and then we try to log in. What? Was that on it? Let's go to English. Please verify that the administration email for this website is still correct. Why is this important? Current administration email is this, so we should probably record this, because this might come in handy. So we've got another something else to keep track of. Let's call this emails.txt. Whoops, I meant to nano that. Paste in this email. So this might also be a username. Prueba? Is that a Spanish word? I'm not sure. Okay, let's go ahead and let's see. Update. This email is correct. Let's just click on this email is correct. Okay, we've now broken into the WordPress application. Prueba means proof. Oh, cool. Learn something new every day, according to Google. Okay, so what can we do? Hey, let's Vancouver WordPress April social hangout. That's gonna be in a couple weeks. Meetup, Vancouver, BC, Canada. That's where I live. Awesome. Anyways, that's some fun. I guess it scraped my IP address or something. Anyways, so how do we take advantage of the application now? So the usual thing that we can do is we can take advantage of we can write something to a plugin. So, man, I haven't done this in a while. Let's see. Let's take a look at the plugins. So installed plugins, Akismet anti-spam, Hello Dolly, theme editor. Okay. So basically, what we want to do is we want to edit the theme code files. So can I translate this website? It'd be nice. Theme editor is already there at the bottom. Okay, so the theme editor is where? Theme editor, right, okay. Create, download, edit themes, great. Let's see. I can't read any of this. Oh, no, I can translate the website from Spanish to English, okay. So, alright. So let's see. Automatic updates. Version 2.8. Deactivate, okay. Maybe we can just... Let's see, add new plugin, plugin code editor. Okay, I think this is it. Bottom of sidebar. Theme, oh, theme editor, okay. Theme code editor, I see. It's been a while, so we're gonna go to the theme editor, we're gonna go to the theme code editor, and okay, we've got editing 2020 to style.css. So we don't want to, we can't inject code into a CSS file, it has to be a PHP file. So I think we're going to access this function, actually no, we're going to access the index.php file. So okay. So the theme is currently activated. Making changes to active theme is not recommended. Don't tell me what to do. Okay, so we've got a bunch of PHP code in here. What we can do is we can inject our own PHP code at the bottom of the code over here. What do we want to do? We want to break into the system. Actually, we don't necessarily need to break into the system right away. We could just try putting in a web shell into this code, and then that means that after we've installed our web shell, we can start running system commands by accessing this this index.php page. So, we need to get some code for a web shell. I think I can just search for something. So this is PHP. So PHP web shell one-liner. Let's search for that. So simple backdoor. Okay, I think I've used this one before. So GroundXT says the code in the editor still looks like CSS. Does it? Does it really? Oh, yeah, this doesn't necessarily look like... This doesn't necessarily look like PHP. Huh. What about this file? No, this is... Okay, this one's PHP. But the index... Yeah, the index doesn't show any PHP. That's funny. But the functions.php one does. Yeah, so we got PHP obviously because we've got our opening bracket for PHP. But can we access this directly from the website? I think we can. So this one is located in the themes directory, I think. Let me see if I can... I need to make sure that I can access this file. So this one's called functions.php. Okay, let's go over to... So what directory is it in? Okay, so we need to figure out... So WordPress, WP Content, Themes 2022. Okay, let's try accessing this endpoint. Okay, so this... Interesting. Okay, so Themes 2022, index.php. This is index.php. So the other page that we were looking for was functions.php. So functions. So this is it. So this is the page that we need to compromise. So let's go ahead and get that backdoor. So the backdoor code is here. So let's see. So this is a pretty easy, this is a pretty simple one-liner PHP code. Let's go ahead and inject this. So we got our PHP inside here. Let's go ahead and There's no end bracket for. Wait. I guess we can inject in online before everything else happens. Okay, so this is the backdoor. So the backdoor works by supplying to this page the CMD URL parameter, and whatever command we want to run is going to be after the URL parameter in this page. So yeah, okay. So we're just going to save this. How do we save this file? Just down here? Okay, so update file. File saved successfully, great. Okay. So let's go ahead and access the vulnerable page. So cmd equals who am I? Okay, we've got remote code execution. So sorry, not remote code execution, remote command execution. So we gave the who am I command, and we got back www data, or as let's see, IPsec likes to say dub data. But let's see what else we can do. So let's take a look at what's in this directory. Okay, so we got a bunch of stuff in here. So from here, it should be pretty easy to break into the server, because we can already run commands from the server by using our injected code in the backdoor. Let's go ahead and set up a reverse shell. So here, I'm going to use netcat to set up a reverse shell on port 443. This is going to open up our Kali box's networking port 443 for potential incoming connections from the vulnerable machine. And to run our reverse shell payload, let's use a little website that I like to use called revshells.com. So revshells.com is a little website that you can use to craft reverse shell payloads for a bunch of different commands, for different OS types. And in this case, well, we need to figure out what technologies, what commands are on the box first. So let's go back to our web shell and let's see if there is netcat on the box. So which netcat? We don't, there's no netcat. That's pretty common, especially since this is a Docker container. Docker containers often are stripped to the bare essentials as far as commands are concerned. So there's no netcat. How about, well, there has to be PHP. So there is PHP, so we could potentially use PHP to open up a reverse shell. What else could we use? Which busybox? That's a good question. So if there's busybox, no busybox here. If there was busybox, then we could use busybox to run all sorts of other commands. But let's see. That's okay. Let's try making a reverse shell payload using PHP. So this is Linux. We're doing a reverse shell payload, and we want to use a PHP command. Okay, PHP exec. Yeah, here we go. So PHP, we're going to run a PHP one-liner command to try to get a reverse shell. Let's try to get a bash shell, and we need to supply an IP address. So an IP address and a port up here. Okay, so this is the reverse shell command we're going to use. We're going to feed it into the backdoor that we introduced. Where are we? Here. Okay, so over here in the command parameter, and paste in our PHP command, run the command, and then we're going to check our reverse shell to see if it was... No, it was not activated. Okay, so what went wrong? Let's take a look. So PHP, it could be that... Well, first of all, I should probably make sure that my IP address is correct. So I've got my IP address as this. It has to be on the same network as the vulnerable machine. So let me just check over here. Okay, so the Docker 0 network is the network that we are interfacing on, and my IP address is this 172.17.0.1. So that's correct. We are listening on port 443. Maybe we should use another command aside from PHP. Let's see, PHP exec. So maybe exec doesn't work. We could try some other PHP functions. Let's try PHP pass-through. So sometimes certain PHP functions work, and sometimes they don't. So we have to try out a few different variations. Okay, let's try this one. Okay, looks like this one didn't work either. Yeah. Let's try another one. We could not try using PHP, and we could go for another command to open up our reverse shell. We could just try bash. Sometimes bash is the easiest way to go. Oh, right. Cyberman Dante says if none of those work, you can upload the entire PHP reverse shell.php file from Pentest Monkey and override the functions file. Yeah, that's true. Well, let's see if we're able to use one of these other commands first. But thank you very much for the suggestion. Okay, let's use this bash reverse shell command. Okay, paste in our reverse shell. Okay, that reverse shell payload didn't work either. So how many more times are we gonna try this out before? We can use curl as well. I've never tried this before. We can use curl to get a reverse shell? That's funny. Let's see if there's curl on the box first. So which curl? There is curl. Okay, we could try the curl reverse shell. Okay, let's try this out. You know what I should do? I should make sure that I have connectivity on the box. We've got ads running on Twitch. When ads run on Twitch, we also do ads on YouTube. And let's go ahead and remember some snowy times. All right, I'm gonna have a little water break. We'll be back in about a minute. All right, everybody, are you enjoying the the free hack in here? If you have any questions about anything we're doing, please leave the questions in the chat. We love answering questions. If you have any questions about cybersecurity in general, I like to help people get into cybersecurity. That is why I'm here. And let's get back to the hacking. Cyber Dante says, sneaky Jay stealing the peanuts. I wouldn't say that the Jay is stealing the peanuts. The peanuts are there for the Jays in particular. They're my favorite bird, and if they didn't show up, I don't know if I'd be setting up the bird feeder. Anyways, what I want to do, I want to make sure that I can communicate with this box. So let's go ahead and what was it? What is it called? TCP dump. Yeah, wait, I need to do sudo. So we're going to use TCP dump to make sure that the machine can communicate with me. And we're just going to run a ping command that pings out to my machine. This is very useful for pen testing in general. Once you get command execution, to make sure that the victim machine can communicate with your machine. Okay, so we're gonna do count 4. Not go crazy. Okay, looks like it's working. Yeah, we can communicate with the machine because the machine is pinging out to us. So I guess what we should do now is we should just use the full reverse shell code. Just like what Cybernerd Dante and GroutGXT suggested. Okay, so let's locate that that reverse shell code. Hold on. So locate php reverse shell.php. We've got a few different ones here. It's so weird it's not working with the PHP files though. I don't know. There might be, so okay, so we got the PHP payloads on rev shells. It could be that it's not allowed to use any of these functions. So it's got to be able to use stuff like the system function or the pass-through function or the shell exec function. But that's okay. Let's go ahead and use one of these reverse shells. So we're just going to copy that file over to our current directory. Then we need to edit it. So we're just going to edit the file. And there's a couple of things that we need to adjust. We need to adjust the IP address and the port number. Because if we don't, then the shell doesn't work and we are very, very sad. 72.17.01. Save out that file. So these are the only changes we need to make to the reverse shell file. Then we're going to grab the entirety of this file and we're going to upload it. We're going to replace the functions.php file with it. So let me go ahead and grab all this. Copy it, and then we're going to go and edit the functions.php file again, which was over here, Okay, so we're just going to grab everything in this file. We're going to delete everything, and then we're going to paste in our reverse shell code. Okay, and then we're going to save this out. Update file. File saved successfully. Great. Now we can go over and access this endpoint. And it should open up a reverse shell connection. Okay, so we see that the browser tab is hanging, which means that we probably have a reverse shell now. So if we look over here, in our shell access over here, we got a connection. We ask who am I? It says we're www data, which means we can call on our favorite hacker friend, who is Scary Hacker Voice Man. Let's call Scary Hacker Voice Man.
It's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we break into a server, and we just broke into this one. Well, Mr. WalkingCMS Administrator, it seems like you're using... What was it again? Oh, it seems like you are using weak passwords for your administrator user. Well, that is a big mistake. we were able to use brute forcing to determine your password, Mario. And love? Well, that's kind of a lame password now, isn't it? Anyways, we broke into your account, and then we replaced your PHP code with malicious code, and then we broke into your server. Maybe you knew about these security problems, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
Okay, yeah, we just broke in. Omega lol. Yeah. Hack the Gibson, love. Anyways, thank you very much, everybody. I only get to put on Scary Hacker Voice Man when we break in, and sometimes we don't break in, and then we're sad. So anyways, what are we doing here? So we're the www data and www data user. We want to elevate our privileges to the root user, which is the highest level of user. How can we do this? So first of all, I should probably upgrade my shell access, my shell, because we're currently using a PHP shell, and it's not super functional. What program can we use to upgrade our shell access in this case? Maybe we've got the script. Yeah, okay, we can use the script. We can use the script program to upgrade our shell access a little bit. But I forgot how to do so I'm gonna have to look that up on HackerFrogs. Actually, maybe script. Actually, what was it? HackerFrogs. Okay, hold on. What are we doing? We're doing reverse shells. Then we're looking for full teletype terminals. So we're looking for the script method. Script. Okay. So we need to run this command. So script devnull qc bin bash. Okay, let's do that. And where are we? Over here. Now we have a slightly updated terminal, and we can continue to upgrade our terminal by using the stty command. So let's go ahead and background our shell with Control-Z, and then we're going to get some settings. So columns 11, rows 27, columns 11, 111. So we're going to use this to upgrade our shell for a better connection. So we would do next we do stty raw minus echo. Then we foreground our process, and then we export shell equals bash. We export term equals xterm. Oh, what was it? Xterm 256-color. And then we set stty rows 27 columns 111. Oh, okay. stty rows 27 columns 111. Then we clear. Term environment variable not set. Huh. Did I use the wrong terminal here? Okay, let me get the terminal. Echo term. Xterm 256 color. Okay, I think I put the dash in the wrong place. Let's go ahead and remedy that. Export term equals. Okay, yeah, the difference is that the dash is in the wrong place here. Okay. Term, why is it not set? Export term equals Okay, okay. I need to capitalize everything. So if you don't capitalize the word term, it doesn't work. But now we've got a fully functional terminal. We can do tab oh, we cannot do... Oh, we can do tab autocomplete. We can do tab autocomplete. We can do terminal history. We can move around in our terminal. This isn't stuff we could do before. And we can also use terminal text editors. Oh, there's no nano here. Okay. Is there vi? Which vi? Or which vim? There's no vi or vim. There's no text editors at all on this. Huh. That's really funny. Okay. So first of all, I want to find out if we've got any sudo permissions on the box. We can look for sudo permissions with the sudo l command, but there's no sudo command at all on this system. So next we can search for SUID binaries, and we search for SUID binaries with this find command over here. So we got oh wow, I think this is it. So SUID with the env binary. I've done this one before, but SUID binaries, what are they? They're binaries that run with the permission of the file owner, and in most cases with SUID binaries, the file owner is going to be root, which means we can run these commands with root permissions. And a good resource for learning about SUID binaries is this website right here called GTFO bins. So this is the link. Okay, so the GTFO binaries is a resource that we can use to look up potential vulnerable binaries inside of a Linux system. So we've got the env binary that is running SUID permissions, or running as an SUID binary. And when we look at this section, it says, if the binary has the SUID bit set, it does not drop elevated privileges, may be used to access the file system, escalate, or maintain privileged access, etc., etc. So we're just going to run this command. So the env, I wonder if I can find. I've done a little slideshow on this before. Let me see if I can find which write-up it's for. I think I'm able to pull it up. Just a second, everybody. I'm going to search. Okay, let me... Okay. Yeah. So let me pull up a previous machine that I've done before, which is the Vulnix basic machine. Let me go ahead and... So you do this stuff for long enough, you start to see some common vulnerabilities. So this is low difficulty... What was this one called again? Basic. Where is it? Basic, here it is. Okay. Okay, so it's not the cup service. Okay, so privilege escalation, SUID env. So the env program in Linux is used to run a command or script in a modified environment. So env, we can run it. We can run a command with a modified Linux environment, I guess, in this case. And if the env program is running as an SUID binary, we can run the following command to gain root shell access. So we run the env command with the sh command over here, and we give the -p to preserve our privileges. And let's go ahead and try that out. Actually, just this right here. Okay, let's go ahead. We're going to paste in our command. Okay, so a good indication that we are not a typical user is by taking a look at the end of the prompt over here. So normal users have the $sign prompt, but root users have the octothorpe or hash prompt. Who am I? We are root, which means...
What are you?
I'm system root.
Okay, we're a root. Great, great, great. Okay, so what we can do is we can move into the root directory to finish the exercise. So in this case, we don't have... GG, yeah. Sleepy Dude, booted and rooted, yup. We got there. It took like an hour and a bit. An hour and 15 minutes? That's not too bad. So there's no typical flag to read on this particular box. So what we're going to do instead is we're going to do a little bit of web server defacement. So web server defacement is basically when you start modifying files to send a message, I guess. And I guess we're going to send a message, and we're going to leave it in graffiti.txt. Whoops. Oh, wow. Let's just run bash. Okay, now we're running bash. So, permission to... Wait. Oh, when we ran bash, we stopped being root. Wow, okay. Hold on. Let's run bash. Okay, now we run bash with the -p so we preserve our privileges. Jeez. Yeah, we're root. Okay. We've got our weird-looking graffiti file. Let's get rid of it. Okay. Let's leave a proper graffiti file. Okay, so what are we going to put in our graffiti file? HackerFrogs rule. And please do not use common passwords for your WordPress CMS login. And definitely don't set the env binary as SUID because it's vulnerable. Love and hugs the shy hat. I don't know. Smiley face. There you go. Okay. Let's see. Get rooted. Okay. Second mind. Not everybody will put Edward Snowden's passport on a website defacement, and it shows the Edward Snowden's passport on a website defacement. I bet WordPress is insecure. Well, listen. Red Sly Fox. WordPress is secure if you keep it up to date. It's just that WordPress has become kind of a poster child for potentially insecure like CMS programs. Let's see. Grout XT says one of the problems with the WP websites is the extendable theme and plugin system, which doesn't have the highest code quality. Yeah, I think one of the things about WordPress is that it suffers from its own success because everybody uses it, and so everybody's looking at different ways to hack WordPress. Another thing is that yeah, everybody's writing these plugins and these themes for WordPress, and they're not necessarily super secure. But anyways, we got the graffiti.txt file, and we gave the administrator some advice, so that's great. Okay, let's get out of here. So exit. And we can, I think we have time for another box, maybe. Let's see, we need to make a new shell access tab. Whoops, I think this one was orange. It's important to have funky colors for your tabs. Okay, so before we get out of here, let's shut down the machine. Let's start clearing out all of our tabs so that we can have something nice and fresh. FTL music, yeah, that is correct. EC Council site. EC Council site. Oh, they put Edward Snowden's passport on the. Okay. That is very cool. That is very cool. EC Council site. Huh. That's kind of embarrassing because EC Council is supposed to be a cybersecurity. It's on Ars Technica. When did that happen? When did that happen? Was that recent? Yeah, but 7-pack. This is FTL music. Yeah, we're trying to play some cool music while we do our hacking. February 2014. Oh, okay. So I guess that was pretty close to when the Snowden leaks happened, right? I need to look this up real quick. Hold on. Okay, this was, yeah, the leak happened on 2013. Okay. Alright, let's download the next container. So let's get rid of the previous one. And let's download the next one. It's going to be from Dockerlabs. Red Sly Fox says, so you started from zero hacking knowledge and recorded and put everything on YouTube? So I studied cybersecurity for a number of years before I started up my YouTube. What year did I start my YouTube? A couple of years ago. So it is, let's see, it's 2025 now. So I guess I would have started my YouTube in 2023. 2023, yeah. And I guess at that point I'd been studying cybersecurity for about 3 years, and I did come from like a zero knowledge background, so I knew nothing. I didn't even know how to use Linux. I didn't know anything about security or coding or Python or anything. But I did watch one great YouTube channel, and it was the Cyber Mentor. I don't know if anybody here's heard of him. Well, I'm pretty sure there are some people here who've heard of him. So the Cyber Mentor, and this was when they still had their. This was when they were still doing like pen test stuff. But I watched one of their live streams, and I really fell in love with pen testing and hacking into boxes and stuff. But I've been at this for about 5 years. And yeah, I mean, you can you can get to where I am. I'm pretty sure you can get to where I am within a couple of years if you study your butt off and eat, sleep, and eat, sleep, and what was it? Eat, drink, and sleep cybersecurity. Basically, don't touch grass for like 2 years. You'll catch up in no time. Yeah, this was during the pandemic as well, and there was a lot of good motivation to keep your head down and do some studying. But anyways, let's download the next thing. So the next box is Mirame. Is this something in Spanish? Red Sly Fox says, if only I had the passive income. Well, if you don't have as much time to study cybersecurity, you can study in your spare time. And I actually, you know what? If you study in your spare time, you have even more motivation to make sure that your study time is well spent, I would say, because nothing is more motivating than working your job and then doing studying like in the like after you've done your job, and with the goal of getting out of whatever job you're doing right now. And you know what? Here's a funny story. I know somebody in cybersecurity. Well, no. I know somebody who wants to get into cybersecurity now, who is coming from like a medical background. So they worked as an oncologist. They work as a cancer doctor for like a couple of decades, and they've always loved cybersecurity, and they want to quit being a cancer doctor and be a cybersecurity specialist instead. That's funny. Let's see. Red Sly Fox says, I'm going the web dev route at the moment because I need a tech job. Do you have a tech job currently? Or are you in the tech field currently? Let us know. So we're downloading. Are we finished? Okay. Let's go ahead and let's deploy this thing. So unzip. Okay, so let's go ahead and deploy this machine. Not at the moment. I went to college for IT, though. Oh, you know, sick in the mind. Jeez, I don't know if I said hello yet, but hello, sick in the mind. Nice to see you here. And why don't I give you a fun little redeem? How about a it's a Unix system. There you go.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so we've got our new vulnerable machine running here. It's at the same IP address. So let's go ahead and do some enumeration. So nmap on this thing. Only one port. Okay. You know, some people say that if you're pen testing a Linux machine, you're pen testing a web server. That always seems relevant because there's so many. All of these challenges for Linux usually have some sort of web app vulnerability to get in. GradXT says, pretty sure the hash-looking thing after you deployed earlier is the identifier for the Docker container. Okay. So I thought this might be Let me go ahead and use some Docker commands. So Docker PS. Okay, so this container ID. Okay, so it looks like this is the container ID because it starts with this. All right. So mirame, is that a word in Spanish? Let me check. Look at me. Oh, okay. Okay. Let's do some web enumeration. So we'll run derb. Index. Oh, that's another PHP application. Great. Index.php. Let's run some. Oh, we got ads. Okay. Ads on YouTube as well. Update tickers for Miram. Oh, okay. Yeah. Let me update my overlay. Where do we do that? Here. Okay. Done. Okay, so yeah, we got a little ad. Oh, the ads ran out. Okay. All right. Guess we're not taking an ad break. Let me have a little water. But Red Sly Fox, are you still out there? And are you interested in learning about web app security? Is that what you want to specialize in when you do? Is that what you want to specialize in when you do cybersecurity? Let us know. 721702. Sometimes the Nikto tool, which is a web app security scanner, can give us some good results. Nikto's a pretty old tool, but there are a few different older security vulnerabilities that it picks up very well. Sick of the Mind says, web dev route is a great way to segue into app pen testing. Yeah, I agree. But Red Sly Fox, have you ever deployed your own applications? Have you ever made a complex website? Let us know. Okay, so looks like we're gonna have to do some more sophisticated directory busting. Let's go ahead and feed it the IP address. So when we use FairXBuster to do directory busting, we need to specify which file extensions to look for. So we got TXT, HTML, PHP, zip. What else could we look for? I think this is a good place to start. So let's go ahead and we found index.php, page.php, auth.php. These are all great hits. Let's go ahead and check some of these out. Where are we? I guess we should probably just look at the landing page first. Okay, so let's reload this. Ah, okay, so this is a login page. Let's take a look at the source code. Okay, so this is index.php. I don't think there's anything that is being leaked out here. Oh, no. So it looks like when we log in, we're making an action, a post method action to auth.php. So username, okay. So here we need a message of an error and exit. Let me translate this. Actually, can we translate it from here? No, we can't translate it from here. Here you can display error or success messages. Okay. Let's see, page.php. I want to check out page.php just to see what is there. Page PHP. Let's translate this. Consultation in the climate. Enter the city. Is this OS command injection? So we're going to enter a city, so test. The temperature is in test is 20 degrees. I wonder if we can inject into this. So we're just going to try some simple injection payloads. No se pudo conectar a la API verifica something API key. If it could not connect to the API, check your API key in connection. Okay, so I'm guessing that the semicolon broke the code. Yeah. And this is obviously not going to work. Oh, could it be that any special characters are going to break the code? So klima.php. So this is another page that we can look at. So I'm just going to copy this. We couldn't connect to the API, verify the key and the connection. So let's check out klima.php. The requested resource was not found on the server, so I guess it doesn't exist. Okay, so this is all we found. We found index, page, and auth. If we go to auth, oh, interesting. What is in this error message? Okay, let's look at the error message is going to be a little bit more clear. So undefined array key username, undefined array key password. Sick in the Mind has an idea. So this is auth.php. So href to, it's just undefined. You know, strangely enough, okay, so it's like var www.html auth.php online, so it hasn't been set as parameters, right? So it's looking for these parameters. Okay. So that means, can we send these as URL parameters? Username equals test and password equals test. Undefined array key password, undefined array key username. So username, I guess this doesn't work. It's looking for a post request. Because, let's see. So, session burp. Yeah, we should probably use burp. Senior Goomba, hello, and welcome to the stream. Why don't you have a nyan cat? There you go. Marco Polisic says, let's see, send his post and use an array, okay. One of the pages had input boxes, would have the request code. Input boxes. So are we talking about the index? So index.php has our login. So we've got our Burp Suite up and running. So we're just going to feed this into Burp Suite, the Burp Suite browser. And Sick in the Mind says curl x post d username. Huh. Okay, I can try that out. Bubbles, Bubbles, are you having fun? Hello, Bubbles, how are you doing? We're having as much fun as we can. Sometimes you got to try the simple solution first. Okay, so this is web enumeration. I have Burp Suite open all the time. Okay, so I think, yeah, it still gives us the same thing. We sent a post request to the auth endpoint. And it still says undefined array key. It's still an error, yeah. So I think we can send the proper request if we just do it if we just send the request normally in Burp Suite. Bubble says this looks like a this looks like a pain. Well, interesting. Let's okay, so we've got Burp Suite here, Burp Suite browser. Let's just do tests. Actually, we should probably test for SQL injection as well. So the user is going to be SQL test injection. It says, So the username or the password is invalid. Let's try using the single quote. Wait, what? After login, you come here? Is that it? So after you log in, you are redirected to page.php. We were able to access page.php without login. Oh man. Okay, let me put on some new music. How about let's see, XCOM music. I love this game. XCOM 2 OST. Let's play some XCOM music. Okay. Here you go, guys. Okay, so it says like climate consultants or something? Let me take a look at this. So klima.php. I'm pretty sure we have to do some sort of injection on this page, but I'm not sure if it's OS command injection or SQL injection that we're doing here. I guess we could, since we already did SQL injection, we could keep on going with the SQL injection. Bubble says, I believe in you. Thank you. Thank you for your vote of confidence. Let's go ahead and try another SQL payload to see if something shows up. Okay. Well, it accepted this. So the temperature in something something. Oh, it URL encoded this. It URL encoded the single quote. Try the other injection one. HTML entity. HTML to entity. I don't, man. There's so many web injections that that I haven't encountered in a long time. It's been a really long time. Okay, let's look at URL encoding. So if we decode, what was it? URLdecoder.com. No, what was it? Man, that took long enough. Decode. Bubbles, can't wait for Binary Hacking Wednesday. Yeah, we're going to be doing a little bit of binary hacking on Wednesday. But what kind of encoding is this? Hold on, let me ask the AI. What kind of encoding? It's escaped special characters for HTML. Okay. It's the apostrophe character. Okay. So how can we... Oh, I substitute hacking for the for that word because I can't say that word on YouTube without the AI going weird and saying that my video is bad. So I have to play the game. But hacking's all about playing the game. So what can we do here? So if the application is URL encoding, what was it? Where are we? Here. I guess we need to feed it some. Maybe we can do this. Ah, okay. So it's gonna URL encode each one of these. illegal frogs. Shut it down. I imagine you saying that in the voice of a certain politician. So what can we do? What can we do if it's URL encoding this? How can we get past this filter? Is it filtering? Oh, okay. So it filters all of these special characters. Does it filter? It doesn't filter this out. It gives an error message if we use the semicolon. And we can't use the hash symbol either. Yeah. Different SQL payload. Yeah, of course. Let me see if we can automate this. Actually, no, we can point SQL map at this page. Yeah, let's try using SQL map and see if we can get a result, a good result. So let's see, post to page. Let's save this and then use SQL map, see if it works. Okay, so request.txt and let's Okay, so I think we can run it from here. So I guess we can call this brute forcing SQL map. just run the darn thing. Okay, so this post parameter is called city. It says it might not be injectable, but we'll see what it comes up with in a little bit. We might have to play around with this to get SQL map to work. But in the meantime, we can probably take a look at the payloads. We can send this through the repeater. City, okay. Alright. We're doing our brute forcing here. I guess it's taking a while. So the post parameter is city in this case. Post parameter city appears to be and Boolean based blind where, oh, okay, it's doing some stuff. All right. Anyways, while it's working here, let's take a look at city. Does not seem to be injectable. Parameter host might not be injectable, so I guess it's not having a. Red Sly Fox, yeah, we're doing XCOM 2 music now because we already ran out of FTP music. FTL music, sorry. Okay, let's go back. So city equals something something. Oh, you know what? You know what else the application does? The application mirrors the result back to us. So if we type in test, it mirrors test back to us. This kind of indicates that this might be server-side template injection. But this is a PHP page. You know what we need to do? We need to try to get the application to do math for us. So we can do, what was it? 7 times 7? What do we do if there's no SQL vulnerabilities? There are a bunch of different... Okay, so this was interpreted literally. What do we do if there's no SQL vulnerabilities? There are other web app vulnerabilities that we can test for. But something tells me that this is communicating with a database. It's got to be, right? Where are we? Okay, so SQL map is still going. So this page here. Another question is, yeah, there's nothing really that we could really get from the page here. We did have the first injection in login. Oh, that's true. That's true. The login injection. So we could probably we'd probably use that one for SQL injection as well. So let's go back. Yeah, that's a good catch, GradXT. Okay, so we're looking at index.php, the post request, right? Let's go back. Index.php, post request, test. Okay, then we can get that request to auth.php. Yeah, and let's save this out. Let's copy the file. Let's see, we'll call this one auth request.txt. Okay, so we've got, man, should I stop this one while I do the other SQL map? Because it seems kind of excessive to have two SQL maps running at the same time. How could it hurt? Bubbles says, is there not a way to use escapable characters to break the string sequence? Yeah, well, I'm counting on SQL map to be able to do that. We could probably, you know, go in and do some manual stuff as well, but let's try doing the automated way first. So let's see, auth. Okay, let's make sure that this is quoted. Two SQL maps. Yeah, we've got the backend is MySQL. We want to skip the payloads. Yeah, let's skip the payloads. Let's see. Two SQL maps form an SQL globe.
We're in. Shall we play a game?
How about global thermonuclear war?
Yeah, this is definitely vulnerable to SQL injection because we used it to bypass the login. Okay, do you want to follow? Let's say no, don't follow. Do you want to retry to find proper union column types with the fuzzy test? Let's follow the recommended. Injection not with null values, do you want to try a random integer for the option? Sure. Post parameter username is vulnerable. Do you want to check testing the others, if any? No. Stick to that. Okay, so Alright. Bubble says, how do I get hacker bytes? You don't well, you get hacker bytes by just watching the stream. So thank you very much for following the kicked droid. Interesting. Great username. Thank you. Thank you very much for following. You're now HackerFrog. You get hacker bytes by just watching the stream, and you can redeem them using the redeem command. So you can do redeem !redeem space I'm root, or go to hack, or frog song, all those other good things. But the kicked droid, why don't you have a hack the planet? There you go.
Hack the planet! Hack the planet! Shut up again!
Okay, so we managed to do okay, so we did it. We've got an SQL injection. We probably want to get the DB. How do you get databases? Hold on. I need to get the I need to get my SQL map cheat sheet. DBMS MySQL batch risk 2 level 2. I wonder why you specify level 2 there, second to mine. Not that I don't. DBMS equals MySQL batch risk 2 level 2 DBS. So okay. I just start there. Okay. Okay, so we've got information schema and users. So this isn't time-based, so we can get all this stuff at once. That's great. You only need to add risk and level if you don't have the POC already. Okay. All right. So let's. So we got the name of the databases. So we got users. We probably want to use. Although, I mean, users isn't actually going to get us very much. There are no other users that. There's only one port. We have to. Okay, so this is the metagaming. So because there's only one port available, we have to use SQL. We have to use some sort of web vulnerability to break in, because there's no other ports to interact with. Okay, we've got ads running again. Let's here, everybody. Here's my favorite video. My favorite video. Well, it's not my favorite video, but it's one of my favorite videos. These are the baby birds having a bath. And enjoy the baby birds while I have a little water break. Okay, so we've got another 30 seconds of ads left, but let's enjoy the baby bird having his little bath. And then afterwards, we're gonna try to figure out how to break into this server. So the GreatXT says, "Cute, kick the other bird out." Well, I mean, the other bird is probably looking for some food. But this guy's having the time of his life. Or her life, I'm not sure. Because these Stellar Jays don't differentiate in appearance between males and females. Anyways, let's man, this is I can't wait for the summer to come back so we can take more videos. Alright, so what's going on? So we obviously have to use SQL injection to, well, maybe it's not necessarily SQL injection, but we have to use some sort of web app vulnerability to get a shell on the system. So I don't know. Let's set up our, maybe we can use SQL map to get a shell. What is that command? SQL map shell. OS shell. Okay. So is it just -- OS shell? DBMS MySQL batch OS shell. Okay. Thank you very much for the help, Second the Mind. It's kind of cheating having a pen tester on in the chat when I'm doing this, but I'll take all the help I can get. What was it? OS shell. Okay, so looks like it didn't work. Actually, you know what? PHP is default. Okay. Yeah, it didn't work. Let's see. Using the default pager. Web server document root. SQL map -- help is the best cheat sheet. Yeah, I guess it would be. I guess it would be. Unable to upload the file stager. Yeah, I guess this isn't working. But I guess we can test for. We can try to get. It probably doesn't have write access. We can try to get the another vector in the admin login. Is there an admin login? Okay, so here's the other page that we're SQL mapping. It's recommended to only use basic union tests if there's not at least one other potential technique. Do you want to reduce the number of requests? Sure, let's say yes. So this other SQL map is running on the climate page, but okay. But what was the? So as users, we can try to get some information out of the users table. So let's see. Is it DB equals users? Look for tables. D users, okay. So D is users. D users. Look for tables. And we've got users. So if the table is usarios, and we're looking for columns. Actually, wait. From here we can just do dump, right? Yeah. Okay. Chocolate administrator. Huh. Interesting. All right. So where is the login page? Well, I mean, if we log in, we already know where we're going, right? Hold on. Log in. Let's say chocolate administrator. Chocolate administrator. All lowercase letters too, you hate to see it. Admin and this password. Yeah, this is the same page that that we see every time. New features probably has file upload. Okay, unlocking new features based on permissions. Yeah, Could be. Let's try a couple of the other users then. So let's try the directory user. Directorio. Directorio? Okay, so how about the Augustine user? Or the Lucas user? We can just try these out. It's not going to take too long. Did I try a Spanish word list? Spanish word list for brute force? Augustine. Oh, interesting. Wait, I think I misspelled the person's name. Augustine. Okay, let me try that again. Augustine. Directory. Oh, okay. Yeah. Okay. Yeah. I think I know what you're talking about. You're talking about directory busting, right? Okay. So locate seclist grep Spanish, subdomain Spanish, common and Spanish, web content, common and Spanish. Yeah. Okay. Let's try this out. Web content Spanish. Okay, where are we? Ferrex Buster. It's possible that we missed something. Well, it doesn't look like we missed anything. We're still brute forcing over here. And I guess Lucas's password is great. Okay. Lucas. So it doesn't look like it's functions based on role. But you know what? We can check the cookies in here just in case. So where are our cookies? Storage. I don't think. Would it make a difference to directory bus with a cookie? Actually, I don't think so, because we were able to access the an admin only endpoint without being logged in. So the yeah. So it doesn't really matter that much. But you know what? Why don't I try some server-side template injection payloads? So let's see. SSTI payload. The WP login from the last challenge. Yeah, that was from the last challenge. Okay, so server-side template injection. What are some? Is there a PHP-based one? Smarty and Blade. Okay. Payload all the things. Oh, okay. This doesn't give you payloads. This just gives you. All right. So we got to try some different payloads. There was I think there was something called, there's an intruder list on payload all the things. You can iterate through Burp Suite. I think I want to do, let's see, flowchart. There was an SSTI flowchart, I think. Yeah, this one right here. I just want to give the test payloads a try. Okay, so start, pass, or fail. So we start with this one, right? So we start with this payload and see if it does something. Okay, so math was not done. Math was not done here. Next we try, if this fails, we try this one. And if this fails, then it's not vulnerable. Maybe it's not vulnerable. Or wfuzz. Iterate. Yeah. Let me grab a payload list. SSTI payload list. Payload all the things README has it, but it's 17.2 degrees there. Yeah, I'm not too sure what the application is doing. So server-side template injection. Wait, where are my payloads? Are there no actual payloads here? This is okay. Where are the payloads? Check the folder level. Okay. Let's see. SSTI fuzz. Ah, okay. Here are our payloads. Great. Let me copy this. So cinematic, yeah. Yeah, you feel like you're doing some cool stuff, right? Now, let's see. SSTI.txt. Okay, and then we need to get a let me go back to Burp Suite. Let me check in on. This is still trying to find the SQL injection. Oh, you know what? I actually already have the request file. I just need to copy it. Let's see, request.txt. This is what we're looking for. So this is the fuzzing point right here. So let's make a copy. Let's call it request2, why not? Okay, and we're going to be fuzzing right here. Okay, so now we can do our fuzzing. So ffuf request2 okay. So we're getting different sizes. The number of words is not really changing that much. Actually, the number of words is changing. What happens if we send this one? Okay. Oh, okay. This is where it's doing the URL encoding. There's also php.md in that folder on payload all the things, so you have character encoding. php.md. Where was it? Ah, okay. Server-side template injection for PHP. So Smarty is a template engine for PHP. Let's see, there's also Twig. Oh, okay. So I should probably go down the list to make sure, well, we can go down the list. What? There was also encoding, right, in here? I don't know. Templating libraries, payload format. Okay, so let's try this payload. And try them one at a time. Ah, okay. This breaks it. So which character breaks it? Is it? It's not the curly braces. It's probably the $sign that breaks it in this case. So if we just send $, actually, so if we send $, this breaks it. It might be Twig. Okay, let's take a look at the Twig injection. Okay, so this URL encoded all this stuff. How do we get around this URL encoding? Oh wait, you know what? Could it be that this isn't this is happening on client side? If it's happening client side, then we might be able to bypass it. Let me. This is to the, what was it, page.php, right? Post. Let's send this to the repeater. Okay. So if we send this, does it get transformed? It does get, okay. Let's try intercepting a request. As much as I hate using the turning intercept on, I hate this. Okay, so turn it on. Wait, didn't I turn it on? Oh, hold on. Sorry, I used the wrong. This is supposed to be page.php. Forward it, forward it, forward it, forward it. Try URL encoding it. So, okay, we're gonna send this. And what is it trying to do? It's trying to URL encode the stuff. So should I just paste in the original contents again and then forward it? Already URL encoded. Okay. Try double URL encoding. Okay, let's send the same. Whoops, that's not it. It's this. So we URL encoded again. What was it? Convert selection. URL can encode all characters. Okay, this looks really messy, but maybe it'll work. Okay, and then we go back, and this is just a bunch of okay. I don't know what this is supposed to be. Yeah, it doesn't look like it's working. But let's take a look at. We're in the middle of trying to do some fuzzing here. Sometimes it's reverse proxy. If it's reverse proxy, double URL encoding will bypass the front end manipulators. It might just be SQL. So what do we got from? So SQL map is still running over here. Sick of the Mind says, I've got an app in my OSWE where it turns double quotes into the same characters, and it turns single quotes into, let's see. Oh, can we escape these characters? I mean, I don't know. I've got a feeling it is STI. Try decimal encoded entity. Decimal encoded. A local SSTI. Okay, so maybe we can try a payload that doesn't involve those restricted characters, just to make sure that it is responding to any of these payloads. So, this makes me think that it's not SSTI. Yeah. Well, it's probably not the Twig engine. So Twig basic injection, Smarty.version. None of these payloads here none of these payloads do not include any of the forbidden characters. So we've got Twig, we've got Latte. Latte is probably not going to work either. PHP system. Find your output location and use an auto grep for that error. You can run an SSTI fuzz list through Intruder. So, how many payloads are there? Let's just get a quick word count on it. So there's 107 lines. Okay, sure. We can try some Intruder. Okay, so Intruder, where are we? Intercept off. This is page. Let's send this to the Intruder. Intruder, we just need to set one. What are these called in Intruder again? Payload point or whatever. Paste in our list. Okay. So we will, what was it? Start the attack. Insertion points, that's what it's called. Okay, so response received length comment. These are all coming back 200. That's to be expected. So take the first one. Take the first one. You mean this? And clicking on it and view the response, find the error in body. This might be a clue right here. So there's klima.php, but klima.php doesn't lead anywhere. So let me just double check that it doesn't lead anywhere. There might be other comments. Yeah, not found here. So if we just... There are no other comments on this page. Try a directory traversal for shits and giggles. Directory traversal. We would... What do you mean? PHP page... Oh, page.php equals file. File equals... the password. Well, we can do some fuzzing. We can do some fuzzing on it. And if it's not going to be page.php, it could be something else. Check comments. Or view source. Let me so the intruder attack. Let me go ahead and one of those was a big response. What? Response received length. Oh, one of them was pretty big. What was it, 4,000 or something? What? Oh, okay. Jeez. Okay. Looks like we've got some... It was just a big payload. Wait, the payload was big? Oh, hold on. So the request was... Oh, yeah, okay. Yeah. The injected payload was big. So the response was big. Let's, Yeah, so these are similarly large payloads. So I guess that's not... Okay, let's do some fuzzing. Let's do some fuzzing for local file inclusion or something. So where are we? Here. Right. So this is just a GET request. Let's go ahead and save this out. Call it lfi.txt or lfi request, lfi rec. I worked through my ad break. I'm not supposed to do that. Okay, let's use FFUF. So before we do that, we need to edit this. So this is going to be fuzz equals okay, let's save this out. So we have to find the list of common parameter names. So common parameter names, okay, rep params. Yeah, so burp parameter names over here. We'll try this one on first. Okay, so we need to filter on file size, response size 1269. Okay, that didn't work. But from here we can try some of the other pages. So page.php, maybe if that doesn't work, we could try auth.php, and if that doesn't work, we could try something else. Hold on. This one is 1852. Okay, this one didn't work. What other pages do we have? There's index.php. So the response here is 2351. So there's page, there's auth, and that's it, I think. So we need to go back to parameter referred does not seem to be injectable. All tested parameters do not seem to be injectable. Try to increase levels and risk options if you want to perform more tests. Probably poke the other databases or tables on the SQL side. Where were we doing that? I think we were doing it. Where were we using the SQL map? Okay. So the other database was information schema. Information. But there's a lot of stuff in information schema. Yeah, there's just a lot of stuff to look through here. Information schema is a built-in thing. The only other database was the user database. Did it outfile to the right web directory when it failed to write the OS shell? So there's user... Yeah, there wasn't very much in... Well, we got all the stuff from the users directory. File read for etc password. File read for etc password. Can we do file read with, Can we do file read with SQL map? I don't think I've done that before. SQL map. You can do it manually. File read command and SQL map. Just grab your POC. File read. File read. Is it that easy? Okay, looks like it wasn't able to fetch it. Debian? This is Linux. Did they mention? Yeah, they mentioned Debian over here. So okay, let's go back to the name of the challenge is look at me. But how can we apply this to our testing? And man, I'm so, every time I see that the user input is mirrored back, I really want to test for SSTI. But how can we get past the URL encoding? So, listen, we have a web app that we suspect is vulnerable to SSTI, but the app URL encodes some characters such as single and double quotes. How can we bypass this filter? Different encodings. Well, let's see what the AI has to say. Okay, using template and syntax without quotes. Okay. Some engines support different delimiters. String construction attacks. String construction attacks. Okay, so there's this one for Twig. I don't know, man. I think the $sign one is gonna have one. $sign one. Yeah, this is still $sign something something wouldn't cause an error because it was bad. Let's see. $sign test. Okay, so that, I mean, this worked, but do we have it do math? This interprets it literally. Test. Okay, so we are pretty sure that we're dealing with a PHP specific templating engine. I think your grep intruder needs a grep filter to see which one reflected. Okay. So this is still, it's still running. Let's see, we got length of... So these were just really big. Yeah, they're really big payload strings. Grab one request. This thing is staring me right in the face. We need the raw output and the response to see what it reflects. Let's just try a normal one then. Klima.php. Maybe it's supposed to be climate.php. Too many things to test. The error specifically, Spanish. Spanish. Klima is Spanish. True. Man, I don't know. Weather, right. Klima is weather. I think I've got to tap out pretty soon. Don't want to end my stream too late. What other awesome InfoSec streamers are on? Stick in mind, so the grep filter, you need to go to the error part of the response so you can add the grep filter. Ah, okay. You know what? I might continue on with this box a little bit later. But Black Hat, huh? The Black Hat Network Operations Center is online. I've actually seen. What are they doing? Hold on. Okay. Looks like they've got some shenanigans going on here. It doesn't. They don't say what they're doing here. But anyways, we might raid into Hobgoblin. They're another InfoSec creator, and they're probably doing some fun hacking stuff. What are they doing? They're doing... Thank you very much for following at Turborelli. Thank you. It's like a webcam in their office, yeah. Okay, we've got some Windows hacking going on here. Looks like some Bloodhound. It's AD for sure. But yeah, let's raid into Hobgoblin. I need to get some dinner. Super hungry over here. Thank you very much to everybody who contributed to chat and to everybody who suggested all sorts of fun stuff for the hacking. Good friends like Sick in the Mind and GroudXT and Husan Hijazi. What else do we have? There was Bubbles in all the implementations. Cypher Enigma, I'm sorry that I missed your your message earlier, but hey, thank you very much for showing up to the stream, Cypher Enigma. And as well as Senior Goomba and Red Sly Fox. Alright, so we're going to be back on... We're going to be back on Wednesday, and we're going to be doing... Cypher Enigma, no! No, please don't cry in silence. Okay, Mirame, what lab is that in? So, okay, let me show you real quick. So that is Dockerlabs, right? So this is Dockerlabs.es. Mirame is the name of the challenge. It's one of the easy level challenges. So the first category is very easy. The second one is easy. It's right after WalkingCMS, and it's over here. So if you want to give this a go yourself, you are very welcome to. And if you're able to finish it, please let me know how you did it. But yeah, I've for anyone who says I'm grinding in a box, your Gucci fam. I'll poke at it. Thank you. That if you manage to figure it out, then I'd be very happy. All right, let's set up the raid. When you arrive on Hoggoblin's channel, please give this raid message: Frog, hip hop, hack, frog. Just like this. We'll be back on Wednesday for more hack and fun. And until then, if you haven't followed, why don't you give me a follow, because you love the cybersecurity content and the birds. Before we go, we're gonna do one last hack the planet.
Hack the planet! Hack the planet!
Hacks Hobgoblin? That's the name, right? I need to double check. Say hi to Hacks Hobgoblin for me, and we will see you next time. Thank you very much to all of our great viewers. We wouldn't be here without you. Rating in 5, 4, 3, 2, 1. Blast off.